Hello, everyone, and welcome back to the afternoon session of today's third Corenect workshop. And in this morning, we have heard so many about the strategy at European and national level, and also the joint vision of different associations, and also our expert groups. Now, in the afternoon, the first session, we will zoom into this specifically for SMEs to listen to their perspective, see how connectivity and microelectronics can create opportunity or even challenges for them. So now we have the first speaker, Werner Haas from Cyberus. He is probably known best for his work on the infamous meltdown and spectral side channel attacks. However, he started his career with ASIC development of Lucent Technologies some 20 years ago and spent more than a decade with Intel Lab working on different CPU research projects before he co-founded Cyberus, where he is responsible for its research activities that typically involve virtualization and cybersecurity topics. So now, Werner, so I don't know, is Werner here?
Yes, I'm here.
Okay.
Let me just pick the right screen to share.
Okay, perfect. Thank you.
Yeah, I don't know what's wrong with the camera. It worked before, but it stopped working now. So let me take a look at the clock so I don't run over time. 5G and beyond. That's the title of my talk, and about sparking a Cambrian explosion in the IT ecosystem. And before I get started, since this is about small and medium-sized companies, I don't know whether you've heard about Cyberus technology or not. We were founded roughly 5 years ago. We started with 6 people. We've grown to approximately 20 employees now. It depends on how you count the students, those doing master thesis, whether you want to count them as employee or not. So it varies between 18 and 24. Our focus is really on low-level systems programming. So everything that has to deal with hardware, hypervisor development, things like that. And our claim to fame that made our company name known to a broader public is indeed the meltdown spectra stuff. And what you see in the background here of my screen, that's a picture, an artistic rendering of the Cambrian time. And the Cambrian explosion refers to a period roughly 500 million years ago. And basically all life forms that we can see now on Earth can be traced back to a relatively short period there. And my statement is, or my claim is, that with the 5G, 6G revolution, we might have an inflection point similar to that, and we can get a lot more diversity than what was there on Earth before. So before the Cambrian explosion, everything was pretty simple. And what we have here, that's a drawing from a relatively modern book on designing embedded hardware by O'Reilly. And it's just a block diagram of a generic computer. And it's fairly simple. You have a main processor on the top left, and then you have the different components there. You have a bus interconnecting those different things. That's all fairly simple, well understood. How does it look like if we just look at a standard status quo system on chips? And what I picked here, that's a block diagram of an NVIDIA product, an SoC block diagram. And you already see at first sight, you don't have to go into the details, but the clear structure is gone out of the window. And it's really complex and messy. And if you dive into this block diagram, on the top left here, you see a CPU cluster called Denver 2. Next to it, you see another CPU cluster with Cortex A57. So those two CPU clusters, they have different processors. Here, you see a Cortex R5, that's yet another processor. If you go over here, there is a Cortex A9, and that is just doing audio processing, nothing else. So on this picture alone, you can identify a couple of processing units. The graphics stuff here, CUDA cores, they are also perfectly capable of running their own relatively complex software. And it's really a mess. How do you design an operating system for such a thing? Typically, when you think operating system, you talk about Linux and Android, and this stuff just runs on this tiny little piece on the top left corner here. So who takes care of system security in this environment? Who takes care of data confidentiality that not somebody down here accesses data that belongs here to the top right, whatever. So we already have in the hardware itself the foundation for a lot more diversification moving forward. And also, if you look at the processors themselves that run the whole show, what you can see here is the evolution of the Berkeley out-of-order machine boom. And the Berkeley out-of-order machine is built on the RISC-V ISA. And RISC-V, some people claim, yeah, well, that's a very trivial processor architecture, 5-stage pipeline. Well, you can build complex pipelines with that simple ISA as well. And here, if you look at the version 3 of that boom architecture, you see a so-called cycle branch mispredict penalty of 12. So the processor itself requires 12 cycles to figure out that he did something wrong. And that was later on the foundation for the stuff that caused us headaches with the Intel processors. But that's also going on here in RISC-V. And what I want to point out here is we have an open ISA that allows us to diversify, that allows us to design relatively simple microcontrollers, that allows us to design processors that could, in theory, compete with a very high end that is currently reserved to the Intel architecture products from Intel and AMD. And in fact, if you look at the United States, just recently there was a startup, a RISC-V startup, a new one, that managed to lure away the top designers, for example, from Apple, and they moved to that new startup. So I think it's very probable that we see RISC-V processor cores that are able to compete with a very high end of Apple processors. And with this RISC-V ISA, we have the opportunity to diversify, and not just on a performance level, but to also integrate some features that we need for connectivity, that we need for security, whatever, into our processors and make better products from that. And let me shift gears yet again, looking at energy efficiency. One of the trademark features of 5G networking is that people say, well, we get rid of all that specialized hardware. We get a lot more flexibility by making everything virtual. And a research paper demystifying the energy efficiency of network function virtualization, they have lots of nice graphs. I picked one here where you can just see the energy or the power consumption of several virtualization features. So Virch.io and vhost, these are two typical features that you find when you do Linux virtual machines. And what you see here in the different graphs at different traffic speeds, kilopackets per second that are being processed, and different packet sizes here from 64 byte to 1.5 kilobyte here in the bottom right. It doesn't matter. What matters here is that we see roughly 20 watts are being consumed just by the virtualization stuff. And a CPU processor die roughly consumes something around 100 watts in the higher end, and 20% of that just goes out for virtualization. So this already tells you that there's a lot of opportunity for coming up with more efficient architectures in order to improve overall energy efficiency. So let me come to the end of my talk, talking about the opportunities for diversification. Pre-Cambrian, we had a very simple ecosystem. We had just a couple of CPUs like the ones from Intel, from AMD, maybe a couple from ARM, and we had a very simple operating system ecosystem. We had Linux, we have Android, we have Microsoft, and that's it. And the Cambrian explosion, to the best of my knowledge, the researchers, they are still not sure what exactly caused it, but they seem to agree that it's rather a complex interplay between a lot of small changes. And the small changes that we have here in the IT ecosystem, we have new manufacturing technology. We heard about that in the morning. They allow us to get to new chips. In the former times, the processor developers, they had their own fabs, and this is now long gone. We have new process technologies, we have new packaging stuff. They allow us to come up with new chips also for smaller companies. We have an open ISA that allows us to develop new processors relatively simple, because we can get the whole compiler infrastructure more or less for free, and we can focus on our own add-ons. We can decide whether we want to have very energy efficient ones, whether we want to have high performance ones, more AI interfaces, more interfaces that are better suited for virtualization. That's up for us to decide. We have distributed systems now, and with that come the requirements for new security models, because frankly speaking, the old stuff where you have a central processing unit, that's gone. Those days are gone, and now we have to figure out how do we manage that. If you are aware of the Intel discussions, you have that management engine that messes around with the main processor. It gets only worse in those system-on-chip designs. And finally, the overarching requirement that we have today is energy efficiency, which requires us to come up with new software architectures, because the Linux monolithic design, where you just have layer on layer and layer on top of that, it's just costing too much energy. And if we want to have communications everywhere, from the small devices up to the data center with automotive and so on, we have to come up with customized software architectures. So that's why I believe we are living in exciting times that allow us for this Cambrian explosion. And feel free to reach out. We as Cyberus, we try to play in the software architectures domain mainly, but we are also reaching out towards the ISA stuff, looking at how computer architecture can make life better for all of us. Any questions to those things that I mentioned so far? If you want to go into detail, just shoot me an email and we can continue the discussion offline.
Thank you, Werner. So I don't see any question from the audiences yet. So if you have any question, please put in the chat. And also, as Werner mentioned, you please send him an email that to discuss further. I think Werner is very enthusiastic in this topic, and he would be happy to discuss with you. And just one small question, when you mentioned all those opportunities for in the processor domain, but if you look at it more in the EU context, so how do you think our small guys, SMEs, can compete giants like Intel, ARM? So what would you see in this kind of new scenario? What would be the opportunities and to against the big guys?
Right. Well, I guess some of my answers are or will also show up later on in the panel discussion. When we talk about that, I guess what we need as SMEs, we really need support of the big guys. Earlier we heard that Nokia and Ericsson, that they have the design houses, and what we need there is the openness for those guys to really reach out to those smaller companies and to tell them exactly what kind of features from a processor perspective they need, so that we can collaborate on designing the appropriate thing. Because right now you just typically you pick the off-the-shelf ARM processor, and that has been good enough, which means you delegate all the responsibility to ARM to figure things out. And I think for the SMEs to play a bigger role in that domain requires us to establish partnerships with the Ericssons, with the Nokias, so that we can come up with the appropriate customized solutions that also benefit those big chip producers then.
Okay, thank you very much, Werner, for your presentation. I think we will hear more your opinions in the panel. So thank you. Now we come to the second presentation. Is from Fivecomm, Manuel Fuentes. He obtained his PhD in 2017 from UPV and co-author of more than 20 international journal and conference papers. Since 2020, he's R&D manager of Fivecomm, where he is currently leading their activities in 5-year Horizon 2020 projects. So now the stage is yours, Manuel.
Hello, can you see the screen?
Yes.
Okay, so thank you for the kind introduction, Janine. So yeah, I'm Manuel Fuentes. I'm the R&D manager of Fivecomm, and today I'm going to talk a bit of about the 5G devices that we are developing for this particular project, 5G Records, which is about professional content production. So just to summarize, I will talk a bit about us first, and then the devices we are providing. And later on, I will explain a little bit the scenario and where our devices are applied in the context of the project. So let's start with our company. So we are an SME that is based in Valencia and was founded in 2019. And we are actually in the UPV in Valencia campus. And basically what we do is to provide 5G solutions for the digitalization of the industry. So we are very focused on business to business opportunities. So currently we are involved in 5G European projects in Horizon 2020. We are working in projects, as you can see here, related to the industry, also to media and to V2X. In this particular presentation, I'm talking about the 5G Records project, which is more, as I was explaining, a media-related project. We are also very involved in Spanish projects, and also we are a part of the 6G SNS initiative. About the portfolio we have, well, we offer a series of products in particular. So we have 3 main lines: digital twin, also net app development. But in this case, in this presentation, I'm focusing on the device layer, which you can see here. In particular, we are talking about the 5G broad module, which is providing connectivity to professional video cameras in the context of the project. And I will talk a bit now about these devices. So the 5G modem currently in our portfolio is divided into 2 main type of devices. The first one is 5G Lite, which is more focused on sensors, and is the first IoT device based on 5G with MQTT connectivity. And then the other one, which is the one I'm talking about now, is the 5G Broad, which is more focused on Ethernet connectivity.
Sorry, is it just me or we lost Manuel?
So cannot hear.
It's not you only, unfortunately. I mean, I can see his internet connection is not too good, huh? Manuel, can you hear us?
Hello, maybe if I switch off my video, is that okay?
Yes, we can hear you.
Okay, sorry about that. Okay. Can you see the screen?
Yes.
Yes.
And can you hear me?
Yes.
Yes, as
okay. Well. Okay, I was saying that, yeah, so that I'm focusing on this 5G broad module, which is it's a modem that provides Ethernet connectivity to different type of devices. So we have robots, cameras, any kind of device that has this type of connectivity. And I was saying that these devices have been validated in the context of several end-to-end infrastructures, in particular Ericsson in Germany, NTT, Huawei, and also Kumukor in Finland. So you have here some details about the product. So it has been designed providing Ethernet connectivity, as I said, and then we have here you have a very simple diagram where the camera is connected to the board and then provides this connectivity. Some characteristics about the device. Well, it has low power consumption, lightweight, and a small form factor, as you can see here in this picture. And then it has it can be integrated or external antennas for midband and 2 in particular for low band. So we have tested it and it works with a non-standalone and standalone and has very easy deployment because it's just installing it, plugging it, and configuring it. And it comes also with a software platform that permits to configure and monitor the performance. About the application scenario, we are applying the modem in this project, which is 5G records, and this explores the opportunities that several 5G components are bringing to the professional media content production world. So it is divided into 3 end-to-end infrastructures, but in particular, we are just focusing on this second one, which is about the multiple camera wireless studio. And I'm talking about this now. So there are 2 partners. Ericsson is about 5G. Ericsson is providing the 5G connectivity, the end-to-end infrastructure, and we are providing the end-to-end, the end devices. And then in the content production part, there are many partners involved and broadcasters, as you can see here, such as BBC or RAI, that are benefiting of our 5G solutions. So the final goal of the project is to develop a complete production system that, thanks to the MPNs and time synchronization accuracy, it enables remote and also distributed production scenarios. And in particular, there are 2. One where a wireless studio is using multiple cameras, and that's the one we are targeting. And there's another one for remote cameras. In particular, the requirements we have seen is that an uplink throughput per camera of at least 50 megabits per second is required, which is quite high. And also high reliability and latency are key in these kind of scenarios. So this is just an image that is like providing the overall infrastructure. Just to summarize, we are here in this part, in the 5G modem part, that is connected to the encoder, video encoder, and then to the camera. And then through the 5G network, there are a couple of gateways that provide this video and audio or any kind of signal that is sent from the cameras to the studio. So in particular for the integration with the video encoding and camera, we are in a first phase where a backpack is provided. And then in the second phase, we are analyzing a form factor for real integration. And finally, in the context of the project, we have already done some tests with our equipment. Here you have a very, a figure showing the setup where a camera is providing SDA video to the encoder, and then through Ethernet and to our modem is, the modem is sending via the air interface to the infrastructure the data. And then through the UPF, this video is sent to the decoder that is showing everything in the monitor. So in this context, we have done some end-to-end latency and throughput measurements, and also some measurements about the stream availability and packet loss. And I will show you now just this figure where this transmitter is just sending some flashes. This video is going through the encoder and then through the modem. And at the network side is receiving, with a 5G dot from Ericsson, is receiving this video. And after the decoding, we are sending everything to the receiver. So these 2 monitors have some diodes here that are connected to this oscilloscope. And what we did is just to measure the difference between the 2 signals, so we could obtain the end-to-end latency. So we got 46 milliseconds for a 50 FPS video. And the 5G latency contribution in particular was around 10 milliseconds, always using ping. Also, the uplink throughput was enough, at least for one camera, because we got 82 megabits per second in the N78 band with 100 megahertz. And last, about the future work. So we are here. We already did this lab test that I just shown. And also the trial network has been done, and there is an update ongoing for release 16. So in this integration now in March, we will integrate also the production side. So the media gateway, the media orchestration and control gateway will be also included. And finally, towards summer, we will do a dry run and finally a final event where all this integration will be showcased. About the modem enhancements that are pending in this project, we are also doing some kind of hardware upgrades. And we are also working, as I said, in this encoder integration. And finally, once we have availability of chipsets, we also perform a release 16 implementation and upgrade of the modem. So yeah, that's everything.
Thank you, Manuel. And so we have a couple questions for you. So who are the potential customers for 5G Broad? And are you looking at customers or rather partners? And yeah, maybe starting from that.
Okay, so the potential customers, I think, are broadcasting companies, media companies, and any kind of company that is, providing content production, professional scenarios, I would say. So remote contribution, yeah. So because the idea is that all these devices, we get rid of wires and then they go through 5G. They are sending all this information. So one of these could be potential customers. And about if we are looking for customers or partners, I would say both, because in my experience, we have looked first for partners and looking at their needs, then we have seen what is really needed, and they are becoming now also customers.
Okay, thank you. Maybe the last question, what is the estimated size of the market? Do you see the need large-scale trials? And if you do, and how are you planning to access such testnet?
Mm-hmm. Yeah, I think that the size of the market is quite large. There are many companies, especially in the media sector, that are very, very interested in providing 5G contribution, at least exploring the alternatives and seeing if it's worth it or not. And then about the scale trials, the idea is first in 5G records to do one, because actually we were targeting very big events for September. But it's not decided yet, but that will be the first one, and then we'll see.
Okay, thank you very much, Manuel, for this presentation, and also bring up this perspective from the media industry, which is not always the most mentioned when we talk about the verticals. I think it's very important to know that their interests and there's lots of synergy there. Thank you, Manuel. So
Thank
next we go to the next speaker, Benoit De Dinechin. Sorry.
De Dinechin. Yes.
Yes. Sorry for that. And he's the Chief Technology Officer at Kalray. He's the main architect of Kalray VLEW core, including its deep learning co-processor, and the co-architect of Kalray multi-purpose processing area family of processors. He also defined the Kalray software tool chain architecture, still contributed to its production compilers. He's currently involved in the development of using this MPPA processors as inline accelerator for DU for 5G O1. So now the stage is yours, Benoit.
Okay, so I'm sharing my slides, right?
Please.
Okay. Is that working full screen?
Yes.
Yes. So I will discuss a little bit what we do in the setting of accelerating 5G infrastructure, and we use many core processor, but what we do is not specific to a particular many core processor. So here is a overall view of what we're talking about when it comes to 5G infrastructure. So on the top of the figure, you see the classic way of doing it for the 4G LTE networks. So basically, you have two big parts: the co-operator part and the remote radio head and baseband unit part, and it's all entangled into proprietary standard. Now, there is a general movement which is called Open RAN, and the idea is to open the radio access network and distribute it into PCs with a well-specified interface, so as to promote vendor interoperability. And this is apparent on the bottom of this picture. So if we go from left to right, we first have the end units, and then we have the radio units where we have the radio transmission. Then it goes into what is called a distributed unit. And I will talk more about this later, because today we're accelerating the distributed unit part. Then it goes into a central unit, and at the end, it goes into the co-operator network. What we see at the bottom is that, in fact, there are opportunity for domain-specific acceleration in each of these components. So you have a very heavy digital signal processing in the radio unit. You have a bunch of processing, a layer 1, layer 2 processing in a distributed unit. And then you have more advanced computation, including application of artificial intelligence. And this is a multi-access edge computing, an ETSI standard, which is located here. And then we have the classical core network of the operator, where it's a virtualized data center environment. So you can have acceleration on all those areas. So this is the general view of the open radio access network. Try to move my slide. Now, if we look more into the details, so it's again the open radio access network, but now we see what are the particular function. And this picture is interesting because you have parts which are typically data center. This time the left-hand side, and you have parts which are very signal processing. That's the right-hand side. But on the central part, the CU and DU, you have a mix of functions which are real-time and time critical, and you have a non-real time. So starting from right, you have the conversion to digital, the low-level 5 function. Then you go into the distributed, the high-level 5 functions. Then you have the medium access control, the radio link control. And then you go into the CU, the control unit. So what was called the base station before has become the association of one CU with one DU. Now, one CU and one DU with specified interface between the two becomes the new base station. But one DU itself can be connected to several radio units. So you have a completely deconstruct infrastructure. Now, what are the interface exactly between those components? In fact, it's in the 3GPP, which is the overall body of standards that proposed the standard for 4G, 5G. It's a third generation partnership project. And they propose that in the chain of processing of a 5G, you have what they call split option. You can decide where you will put the boundary between the different parts. So you again see the parts, radio frequency, low fi, high fi, low MAC, high MAC, low RLC, radio link control, high RLC, packet data conversion protocol, and the higher control function. Now, below we see what are the layer 1, layer 2, and layer 3 functions. So layer 1, I recall it's moving the raw data and doing the basic bitrate control. Layer 2 is dealing with data transfer between adjacent nodes and doing packaging and depacketization of data into frames. And then you have the layer 3, which is more the network layer, where you have routing and switching based on logical addresses. Now, what is interesting is that it's well-defined thanks to 3GPP, where you can put the boundary of the different part of your system. And you see here, you have the radio unit, the distributed unit, and the central unit. And you can decide where you are going to cut that, and even the boundary between those three components. So for instance, what is the mainstream organization right now is called the split 7.2. So you split between the radio unit and the distributed unit between the 5 function, and then you split again the distributed unit to the central unit at what is called option 2. So it's between the radio link control and the packet data convergence protocol. So just what is the top picture and what are the choices? You have also other choices like the small cell forum, which is more interested in small cell deployment. They will split at option 6 between the high Phi and the low MAC. Now, we go more into details. So what are we doing in Kalray in particular? We are putting acceleration based on multi-core technology in the distributed unit. And this is this time for ORAN. ORAN is not Open RAN. ORAN is a particular alliance of industry actors that provide more detailed specifications than 3GPP and provide software models. And they team with the Linux Foundation in order to have a all piece and interface to be tried and swapped and experimented with. So for the DU acceleration, they propose 2 scenarios. The top scenario, which is called the look-aside acceleration, and the bottom scenario on the picture, which is the inline acceleration. So what happened in the distributed unit? It's receiving data from the radio head, the remote radio unit. So here you have a packetized, you have data, which is in fact radio data already in the frequency domain, which is sent what is through Ethernet based networking, which is called the front haul interface. And you have here the data which arrive in the looker side. You have a main CPU offloading compute intensive function to accelerator, which are hidden between an hardware acceleration abstraction layer. And this is the look-aside acceleration that you find typically like on the FlexRAN platform from Intel, where they will call the FPGA, for instance, to do the LDPC decoding. Now, when you have a more programmable platform, you can switch to the bottom picture of, and so you assemble your distributed unit by having a general purpose CPU doing the upper function of layer 2 and receiving data from the whole pipeline coming from the frontal interface. You have all the functions that are done inline, most of the L1 function, and then you go to the beginning of the L2 function, and here you use one interface, one which is well known is the FAPI, which is the non-network version of the small cell forum that I mentioned, the option 6. So this is the overall view of what you can do. And as we do that in a particular processor, currently it's a 16 nanometer chip with 80 cores. Each core has a deep learning accelerator, and it's quite capable also in floating point and signal processing. But it's called a many core because instead of having a flat multi-core processor with the same memory hierarchy shared by all the core, we have components which we call compute cluster, but they are like compute units of an AMD GPU. So we have on those the compute cluster group of 16 core plus local memory plus DMA engine. And this is in fact a feature of a many core processor, that is, you see an intermediate architecture level between the whole processor and the individual core. So with this kind of machine, in fact, you can be quite effective at acceleration. So this is more details on what we are doing today. So we are developing the software for the distributed unit using the ORAN split 7.2. And so our processor receive through a quad link 25 gigabits, the data from under the format called ECPRI, that is enhanced common public radio interface, and where you have the data from the radio unit, and then we do all the L1 processing, and then we pass on to the x86 through the FAPI interface. So what is heavy here? It's mostly functions that at the end would deserve a dedicated unit, and it's mostly LDPC decoding and channel estimation. So I will conclude for what we envision after a while doing this, because it's not finished. What we see for EU technology is that in a 3GPP set of standard, in fact, you have different use case classes. In particular, you have the enhanced mobile broadband, so you have a multi gigabit per end user. You have the ultra reliable low latency communication, and this is more focused on very high reliability and very low guaranteed latency below 1 millisecond from end to end. And then you have the massive machine type communication. This is more for cellular IoT. Now, when you have accelerator, which are not ASIC or FPGA, you can do a good job, and this is at least what we try to do on the ultra reliable low latency communication. And this particular use case is applicable to Industry 4.0, where it has to be combined with time-sensitive networking on Ethernet. This is another very important piece of technology and emerging standard in deployment. You have the 5G private networks, mostly hospital, airports, stadium, and other medium scale deployment. And what is just the challenge is that you can put a lot of things in software, but then you have to ensure the worst case latency. When you see 1 millisecond end to end, it means that you have to deal with hundreds of microseconds for the individual task. And this is especially a challenge with classic CPU and GPU processing because of the very deep memory hierarchy, and with regard of CPU, the full coherency model of the global memory system. But when you work with many core accelerator and programming models, you have opportunity first go through domain-specific language, because the processing chain you have in 5G, they are evolving, they are changing, but not at the same rate as packet processing. So you cannot apply a classic data flow, but you cannot do a raw, very low-level coding either. And when you have this, you can leverage in a well-automated fashion the local memory, the engine of your platform, and this promote energy efficiency and, more important, time predictability. And if you're also able to act on the architecture part, you have opportunities to add dedicated or configurable function for what is heavy and more or less stable with regard to interface. In particular, in channel estimation, classic technique is using FFTs, and now there is a move to leverage machine learning techniques. Thank you.
Thank you very much, Benoit. And so, okay, I see there's some question from the audiences. And how far, this is question from Bernard, how far success of your accelerator depend on, okay, sorry, I have to go back here.
I try to get.
Yeah, accelerator depend on partnership with other established vendor. For example, the FlexRun platform, what you mentioned for virtualization run.
Yes, so it's very difficult to enter into a closed ecosystem. The FlexRun platform is closed. It's only partners and chosen partners of Intel that can have access to the source code, but they are open source software alternative. And us, we work in particular with the Open Air Interface project, where they are all the chain of 4G, and now they are completing the 5G. But we do that as a way of demonstrating how all the pieces come together. Now, of course, we do this work in combination with the telco operators and the infrastructure providers, and they will substitute what we have from the Open Air Interface code base by the proprietary algorithm. In particular, there is a lot of value in channel estimation techniques. So the point is that we have to demonstrate the whole thing, but we use piece of open source, which are, by the way, enhanced by all the contributors. But at the end, when it goes to a telco operator, they will substitute the most critical piece instead of using the open source base that we use. And of course, we don't have access to the FlexRun software.
Thank you. I have another question, possibly you have addressed partially from Jack. So again, who are your customers or partners? I think you have mentioned already.
Yes, I don't know if I have all the name in my head, but we have Atos and we have Orange, and we have another EU telco. I don't remember if it's Spain or Italy. But I'm doing the technical part, so I don't see the higher part. But it's connected. It's a joint project with the big EU telco partners.
Okay, great to know. Thank you very much, Benoit, for this presentation. Later we'll hear more from the chat panel. Now we move to the next speaker, Paul van Dijk, who is from LioniX International. He received his Master and PhD in Applied Physics from Technical University of Eindhoven and a Master of Business Marketing from DS Nimbus. Since 1999, he has worked 11 years at ASML and was responsible for new business development and product marketing and special applications and 300mm business unit. He is co-founder of Satrux, and he acted as CEO a startup on integrated microwave photonics, and it was merged to, of course, LioniX International in 2018. Now he is acting as Vice President of Strategy and Innovation. Now the stage is yours. And sorry, just want to check, is Paul van Dijk in the audiences? Okay, if not, because of our time is running, so maybe we can go to the next if Paul come back later. So before end of this session, we can restart that part. So now we give stage to Sebastiano Bertani, and he studied telecommunication engineer and Politecnico Milano and the UPC, and have an MBA as well. And at age of 14, has already founded a startup, Skynet, an internet, and later he worked in cell telecommunications, Accenture, fluid mesh networks. In 2010, he founded Tanasa, and currently serves as its CEO, and he is also a representative of European Digital SME Alliance, and he participates in the expert group related to radio equipment directive, focusing on the topics of software hardware disaggregation, systems reconfigurability, and horizontal market creation, as well as twin transition. So, Sebastiano, now the stage is yours.
Thank you, Anine, for the kind introduction. Can you guys hear me properly?
Yes.
Okay, so let me just share my screen and in presentation mode. Okay, so we'll spend the next 15 minutes approximately to talk about digital sovereignty from the hardware perspective. Again, my name is Sebastiano and I'm CEO of Tanasa and also a member of the European Digital SME Alliance. We are basically the first and largest ICT SME association with more than 30 members and represent more than 45,000 digital SMEs across Europe. We basically bring together all the knowledge from the industry to identify the trends and steer them to what we consider a better digital future, focusing basically on all the digital enablers. Now, I'm going to talk today about sovereignty. In the earliest presentation today with Marco Ceccarelli, basically the need to bring back some leadership in the production and manufacturing on the hardware side of electronic components was discussed. So that's one important aspect of getting back, let's say, the power. The other component that is important in technology is, of course, the software side. So it's pretty important to consider what can be done also on that side to foster sovereignty, not only for 6G, but in general for all the technology. Now, the relationship between software and hardware is pretty delicate. Most systems, especially traditional systems, we're all, let's say, familiar with, like Apple devices, are vertically integrated, or pretty much most of the vendors in the industry act traditionally as a vertically integrated companies that provide software and hardware connected together. This creates a big amount of problems, mainly the lock-in. So there is not an easy way to extend a system with third-party devices. The switching cost is high. You're basically prisoner of one company. And if you apply this to a country level, you have that situation where you really depend on other countries for your sourcing needs. And this becomes a problem and literally takes away the sovereignty. Now, the other potential architecture and the relationship between hardware and software is what is called a modular approach, or a disaggregated approach, or in some cases it's called the horizontal approach. That one can be complex because it requires many entities to talk and to coordinate. That may require standards, which are basically a formal way to say how things have to be done together, and they require legal clarity. Otherwise, it's very complex to understand who's responsible for what. Now, the horizontal structure is the one that can actually foster the digital sovereignty for a few reasons. If you think about it, sovereignty is all about having the freedom to make choices from different sources. So sourcing this component from one player, that component for that player, some of them from within Europe, some of them from outside Europe, without any lock-in. And another advantage is that European software companies, and if you think about it, we have more software companies than hardware companies. Hardware companies are traditionally somewhere else, let's say. They could leverage a good relationship between hardware and software and a good architecture to build value on top of the hardware without being locked in some way by the hardware. So that is also something that is possible with an horizontal structure of technology. And overall, this would create less dependency, which means increased sovereignty. There is also another aspect that comes with the horizontal structure and disaggregation, which is the impact on the twin transition. So we want the future to be more digital and to be more sustainable. The good news is that a horizontal architecture with modular components on the software and hardware side allows the same hardware to be reused for maybe even different uses over the lifespan, and of course allows to extend the lifespan. If you think about the linear business model of hardware companies, they want to launch the next product, and then as soon as it's out, they want to go and focus R&D resources to build the next product that they want to push out. And usually the alternative they give to customers is to, trash away the old hardware to put there the new hardware, which comes with a vertically integrated software. If the model were different and it were possible to buy hardware on one side and software from a different company, a new type of companies would be born and would expand. Companies that basically provide software and services to hardware that would be otherwise not even maintained, would be obsolete, basically. So the effect would be very positive also in that sense and would foster the circular economy. Now, what is needed for this to happen in a faster way? Within our involvement with the European Digital SME Alliance and the work that we have done within the expert group for the Radio Equipment Directive, we identified a few areas that are pretty important in terms of what can the policymaker do to accelerate this. And one of the most important areas is related to the framework of allocation of responsibilities. If you think about it, in a context where it's very clear that we have an horizontal situation like train transportation. If there is a train that goes out of the track and there is some accident, it's pretty easy usually to identify, was that a rail problem? Was that a train problem? And you have different companies with different responsibilities, and no one sees that as obscure. But if you go to technology, it's very difficult to understand when the system is creating some issues. Was that a hardware issue? Was that a software issue? And so the result of this uncertainty is that companies are free to go to the market in the best way they think they can be successful. So what they do is usually they tend to be that push towards the integrated model, to the model where they control both software and hardware, and they kind of don't want to take extra potential liabilities that they would not be able to control. Basically, there is uncertainty, And this uncertainty makes it very difficult for the horizontal market to be created. And this, in turn, makes vertically integrated companies more successful, and that means hardware companies. And as final result, we basically depend more from the outside of Europe and from the inside, even because of this result. So from the regulation standpoint, it's very important that clarity is provided, and a lot could be discussed in the red regarding this topic. A second element is a proper cooperation with standardization bodies to promote and foster open standards and open interfaces. They are in practice the way different companies can operate on multiple components, not only hardware and software, but even hardware and hardware or software versus software, to be able to put together a disaggregated system that basically gives all possible combination and choices to whomever wants to use them. The third one is financial support for European SMEs. Digital SMEs are a very strong asset, and most of the innovation comes from there. There are very good programs that the European Commission is launching and that have been launched in the last few years. So I think in relation to this aspect, a lot has been done already. And the last item I have here is really a sort of question. In the industry, everybody is excited about Open RAN, and that set a sort of very important milestone. But in some way, the penetration of Open RAN and disaggregated system is still very, very low. So in some way, 5G, it's already too late. I think the big question is, will we be ready for a fully disaggregated and horizontal market systems when we have 6G? Will all the system be ready from all these aspects, from the legal aspect, from the regulation aspects, from the standardization aspect? I think that's the kind of question we will have to ask, because that's key, together with bringing back some of the production for a stronger level of sovereignty. Thank you very much.
Thank you for Sebastian for the presentation. And any question from the audiences? So maybe one question relates, because I think you have gave a great introduction about, especially related to the opportunity with O-RAN, which is, I think, you will be intensively discussed in the panel session. So if we look at O-RAN, that's many of those advantages will go to the hardware, as you mentioned, and Europe now is not in a very advantageous position respect to that. So what do you see would be the opportunity, exactly winning point for European SMEs?
Well, I would say Open RAN is a very interesting, or let's say the telecommunications side of disaggregation is a very interesting area for SMEs, because if you think about it, till yesterday, no company could actually jump into the nice architecture that we saw in the previous presentation, and let's say focus on one component, build some software specific for that component, and add that value there. Either you do everything or you don't do it. You can't do anything, basically. So with this disaggregated situation and Open RAN, software companies, so digital SMEs, can basically jump in, focus on a specific problem, be the best at solving that problem, and they would have a market, which otherwise wouldn't be there. So I think this would be the most important opportunity. And I think we have a lot to say in Europe, because we have great SMEs all around the country that can actually do their legal contribution in each of the different components of the system.
Okay, thank you. And I have another question from Gerhard. Could you please tell why do we need to drive for this disaggregated RAN, and what are the key benefits?
Well, the reason why we want to go to disaggregation is that we want to give the freedom to let me pick an example. Let's use an example that everybody can use. So if we imagine a European family that is in love with a very famous brand like Apple, and everybody in the home has an Apple smartphone and then some Apple computers, the advantage that they would get buying another device that comes from the same company, which is fully vertically integrated, hardware, software, services, is so huge that it's a no-brainer, right? Now, this is if we see that in the positive way. But if we see that in a negative way, we could also say that there are huge switching costs for any customer to mix and match different vendors. So the main vendor that uses this power can force users to stick with that, and that not necessarily translates into an advantage in the long term. So if we imagine that same family that can basically mix and match different system and devices, maybe, I don't know, we have grandpa who doesn't need that super powerful iPhone, we can buy something different without too much complexity. Usually it's like, forget about it. If it were easier to do this, we'd have an advantage in terms of cost reduction, but also in terms of flexibility and freedom. So reducing these barriers to mix and match things is what is needed to get that freedom, depend less in this specific example on a company, but if you apply this at a broader level from a specific country manufacturing a specific type of chip, or because you can't run in software unless you have that chip. But what if you could run the same software on a different chip? So this is just one example. So this level of freedom and of decoupling is what allows being less dependent on single entities that would have more power otherwise. And this is, how I call getting back some sovereignty, basically.
Okay, I think there's a comment from Bernard that maybe running investments correspond to 3% of costs. Maybe from the diversification point of view, cost is a good advantage. Yeah. Okay, so thank you very much for the presentation. Appreciate it. Now,
thank you for having me.
Back online. So he was unfortunately disconnected because of a network problem. So I hope our reliability will, improve to be 99.999%, and this will not happen again. So now the stage is yours, Paul.
Thank you. I hope you can hear me. Yes. Okay. Let me see. Thank you. Yes, Paul van Dijk from LioniX International. Let me put this one back on again. Click. Yes, I'd like to talk about electronic and photonic novel key enablers in the 5G false network architecture. My name is Paul van Dijk.
Sorry to disturb, Paul. I cannot see your slides. Maybe it's also
you cannot see the slides.
Yeah. Okay, now.
Ah, yes, I see. Yeah. Okay, so this is the yes. Okay, I'm up. LioniX International. Yes, I work for LioniX International. We are based in Enschede. We are 50 people, and our core business is integrated photonics. It means photonics on a chip. And I will explain how we need electronic components to drive a network based on a 5G FOS architecture. 5G FOS was a Horizon 2020 project, the second phase project, which started 4 years ago, and the results are now available. The project is successfully closed with more than 14 partners. We worked very hard to make this network available. If we dig into the architecture of the network, at the left-hand side, you see the familiar architecture that you know from the central office over an optical fiber transport of the signal to mobile network operator equipment. So where you have your access of for your mobile phone. With the 5G FOS architecture, we introduced a middle layer in the analog domain, where we have some key features that we manufactured in the project. One is what you see there is the master flex box. This one puts signals over an optical fiber with different colors. In the project we use 4 colors with using a reconfigurable optical add-drop multiplexer, short for ROADM or long for ROADM, which feeds a rooftop antenna. And this one acts as a hotspot at 60 gigahertz and feeds with these millimeter wave some lamp post or slave post. And the rooftop antenna is configurable through a optical beamforming network, OBFN, which is manufactured by us. So we see several key components in this architecture, which is actually an architecture with the coexistence of both digital and analog. Then how can you deploy this architecture? You can deploy it in several splits. So you can use the front hall split in here, or a mid hall split, or a back hall split. So it's very reconfigurable and very flexible in the deployment for a suite of applications and access throughput. So here you see again the components that we developed under the 5G FOS project. So the deployment, one of the 3 use cases is actually a stadium of PAOK Thessaloniki, who was also a partner in the project, where we used the baseband unit at the left, which feeds 4 different colors to the ROADMs in the networks, which then split it to the access points, or to the rooftop antennas, as we call them, that can then be configured to get sufficient coverage over, for example, this stadium. So there was about 6 months ago, we had a nice demonstrator there, and we showed that the whole system worked. So what you can see is here we have 4 colors. The ROADMs are configured in such a way that we can put every color at a certain step to the lamppost antenna. So we can, this configuration is yellow, green, blue, red, but it can also be deployed differently. So the total capacity that we fed into the system was a world record, demonstrated already 3 years ago, and also published in a Journal of Lightwave Technology. So the core, the whole throughput of the system was 24 gigabit per second, with, and then here comes your power contribution with only 12 nanojoule per bit in terms of power consumption. And this was achieved using 2 gigahertz of bandwidth in the 60 gigahertz band, which can further be broadened to the full 7 gigahertz bandwidth to even reach a higher capacity in this architecture. So then what does the hardware look like? The hardware was developed in the project. So at the left-hand side, you see the FPGA, the digital signal processing, which then turns into electronic analog processing. And then you see some discrete components that are addressed there to convert the electronic signals into optical signals, or transfer it from optical to the electronic domain. So you see discrete photodetectors with transimpedance amplifiers to pump up the signal. And the other end, you see the EML and drivers, the external modulated laser, to convert the signals into the optical domain. So this shows one transmit and one receive line. Of course, this is all capable to do 4 transmit and 4 receive lines, as you can see. So typical throughputs here that were reported by Mellanox or NVIDIA, who manufactured the FPGA, and the RF SOC is typical 2 gigabit per second for 4 bands using QAM16, and the digital processing doesn't add a lot of noise to the signal, which is also important. You see also a limited number of lost packets that were reported here. So this is the powerful concept of using digital and analog and RF electronics and RF photonics. Going then to the next component, the ROADM. So this is in fact a chip that we manufacture here in Enschede, and it splits the 4 optical lines. So around 1550, around C-band, we use 4 different channels to split. It has 18 dB crosstalk, as you can see, and it has a very nice response. At the top side, you see the ROADM, which is reconfigurable, and that is done by these homebrew electronics to control it and to switch the different colors into different fibers, as you can see in the blow up at the bottom side. So the size of this ROADM is about 10 by 5 centimeters. so it's fairly compact. Then if we go further in the network to the configuration of the phased array antennas, that is where we use these beamformers to use broadband, squint-free, configurable coverage and capacity. So we can actually shape the beam through these in transmit and receive 8 antenna tiles. The antenna tiles were manufactured by Siklu in Israel, and hereby we can change the timing on the different arrays and thereby steer the beam. So we use true time delays in this configuration for both receive and transmit, and this is why we can achieve 7 gigahertz of bandwidth squint-free over very, very large angles. So it's fully configurable, the network with that. So then the conclusion of this roadmap, what we have found is that we really need the co-integration and the miniaturization first of the electronics, also of the photonics, and probably of both, which enables low cost and robust functional components and systems. It enables also electronic and photonics functionality in a package, very compact, and it enables low power and high capacity configurable networks. These are the references to the recently published articles. One is about to be coming out, and that is the one on the analog and digital coexistence, which is the third one. Here I also want to thank all the partners who contributed to this project, with whom we collaborated. There's also a link to the 5G False website, which is still up, and there's much more information there for your convenience to look at. And this is my closing slide. LioniX, we've been in the business for 20 years, so this is where we celebrate our 20th anniversary this year, and we are very involved in the activities in Europe related to integrated photonics, to mention ActFast, Photon Hub, and many Horizon projects. Thank you very much.
Thank you, Paul, for the presentation. And so maybe there's a question from Jack, that what kind of opportunities do you foresee in the near future for European SMEs working in photonics with advent of 6G?
Yeah, so although we are a very small company, we are not an SME anymore. The point is, if you look at these complex network, you are, as Piet Wambeck said this morning, you're already looking at architecture and you are developing a component. There's lots of novel ideas to develop new components. So for any SME, there's a lot of innovation possible on the component level. We have been looking at the assembly that you see here, the strategy to combine different chips together on one assembly. We started with that 30 years ago, and now we have a suite of novel applications, both in computing, in communication, in sensing, everywhere where you need photonics capabilities. We can make it now very compact. So there's plenty of niche applications for SMEs to collaborate with us and with others. Thank you.
Thank you, and great to know that. And so I think with that, we can conclude this session. Thank you all the presenters and speakers from SME domain. And we will have a break, short break, and until 2:50. So in 7 minutes, we will start the next session, the last session of this workshop. See you. Hope you have enjoyed so far. After we have just went through and zoom in on the SME, now it's going back to more strategy level. So as some of you may know that last November, Corenect published its white paper on European strategy in the domain of connectivity and microelectronics. And so far there has been more than 1,000 downloads on this white paper. And so today it's our happy it's our pleasure to have the lead editor, Frederick Tillman, and Patrick Peep, to discuss about the strategy vision we are developing inside the Corenect from the white paper, and also the initial analysis of investment requirements that will be supposed to be delivered in end of March. So now I first introduce the speakers. Frederick Tillman is heading the Integrated Radio System Department and Ericsson Research, with focus on both cellular infrastructure and device connectivity. Besides being responsible for several internal R&D activities, Frederick has been the Ericsson driver for multiple external collaboration projects within the framework of Horizon 2020. Next, Patrick Peep is Director of Strategic Partnership at LXP Semiconductors and has held this position since 2012. He is the chairman of ANIA's Technic Expert Group since 2018, and he's member of Insight Steering Board since 2015. He was co-chair of Overall Excel Strategic Research Agenda 2019 to 2021, and is also co-chair of the chapter Transport and Mobility. He was also chairman of Engineer Alumni Association at KU Leuven from 2005 to 2008. So now I give stage to you, Frederick and Patrick. And Frederick, we cannot hear you.
Frederick. We don't hear you, Frederick. You're still on mute.
Okay, let's see.
Now we hear you. Yeah.
You hear me now?
Yeah, now it's okay.
No, it's okay. Okay, perfect. So let's see if I can manage to share my slides as well. I'm running the WebEx web interface here, so let's see if I can do that. Okay. I'm not able to share on my side. Would it be possible for you to share, Patrick? I need to apparently download the app in order for me to share, which I haven't done.
Patrick, we cannot hear you. Okay.
Okay, so I was saying that I can share. Now you should see the slides. Is that correct?
Okay. Perfect, Patrick. Thank you very much.
Put it in presentation mode, and you can just let me know when you have to go to the next one.
Okay, perfect. So we can go to the, we can go to this page. Just setting the scene here. As Jan-Inge said, I mean, what we will discuss here for 20 minutes is the white paper that was published last November. And this is basically to highlight the work we have done in the project and try to put forward some of the main concerns we have for Europe and some challenges we need to address. So the background here is that, as you're all aware of, that connectivity, intelligence, and sensing, and all microelectronics and software has really made tremendous, progress over the last couple of years, or decades, you could say, but especially now the last couple of years since we have had 4G and now 5G in place, etc. So if we look at the overall value chain for this big business, we realize that it's one of the most complex and interesting and global supply chains you can imagine. Basically, in order to have all these nice features on the right-hand side in place, everything being connected, etc., you have a very delicate supply chain leading to those products, starting with some raw materials, you have chemicals, you have programming, you have fabrication of various kinds, machinery, very advanced lithography, etc. And this supply chain really goes across the globe at least once or twice before you reach the end products. And what has happened now is that basically everything we sell to end consumers today is being dependent on this value chain, on this supply chain. That is the reality we're facing, and all the weak spots, all the narrow segments, etc., are painfully getting to our awareness, as we have seen the last couple of years where we have this shortage and everything that you're aware of. So this is the big context here and the big challenge that we face. How can we manage this from a European perspective in a good way? So if we take the next slide, Patrick. The big challenge then. Oh, no, you're sharing the wrong slide deck, Patrick. Not the one we have in SharePoint.
Ah, okay, then I have to look.
Because you missed one slide.
So maybe, Alex, maybe can you help here?
Yeah,
Actually,
I can go
I
to
have
the
the same.
SharePoint, no problem.
I think I have the same version here. Actually, the one that has been uploaded this morning.
Yes, but there it's an updated. The name is the same, but I think the slide should be updated.
But again, what I have, Frederick, is the following. Okay.
Yeah, but if you go back one slide, there we go.
Oh, okay.
Exactly. So if we go back to our story here with the supply chain, we realized that when we composed the white paper, we wanted to exemplify what has happened to the car industry that is apparent to everyone because we all use cars in our daily lives. So we see what's happened the last couple of years. We realized that that journey will be applicable to all other ecosystems or product domains, meaning that we wanted to create the story for this. So this is what you will see in the white paper. And the core essence is that if you study the car, you realize that since the days of the T-Ford 1908 till roughly 100 years later, some 10 years ago, the car industry had pretty much the same KPIs. It was all about improving mechanics, having, let's say, performance in place, having a powertrain in place, having engines that were really good and consumed less fuel, etc., more horsepower, etc. And that journey we have seen for decades. Now, since the launch of Tesla Model S or so, some 10 years ago, we have seen an accelerating change in the car industry, where the car is not longer looking like you see here on the left-hand side. It can almost be like a computer on wheels, as you have on the right-hand side. Of course, it's exaggerated a bit, but this is what we see for the future, where the car will become maybe the most complex computing platform a private person will own or get his hands on. It will be a very, very complex product. And it's all due to the microelectronics and the software that is now poured into this product segment. And this will change the industry fundamentally, and more importantly, where the value ends up. So if we go to the next slide, Patrick. If we look at some classic European strongholds from the past, Europe has been tremendously good in building cars. We're still leading this market. It's a really good stronghold for Europe. But the classic KPIs where we have excelled, they will in the future become weaker compared to other KPIs that are currently surfacing or getting more and more pronounced in marketing and in the capabilities of the vehicles. So you see here that the scales will start to alter. It's not about the engine anymore, the performance, the gearboxes and so on. Instead, it's about the chips, the connectivity, the entertainment system, how the car will connect to your digital ecosystem as a private person, etc. All those values will gain importance and become more and more, let's say, key essentials for the value of the car. And as you see here, we will have an accelerating shift of value going from left to right in this picture. And if we look into the geographic where we have the ecosystems developing this, we see there will be a transition then from the European ecosystem as we know it today to other ecosystems like in Far East, US, and so on, where we have a real strong footprint when it comes to the systems here on the right-hand side. And this is one of the key challenges for Europe. How can we change this a bit and get into those bigger value ecosystems that will sort of define the cars in the future? Go to the next slide, Patrick, please. So if we look into microelectronics and what would it take for Europe to really get a larger piece of the pie, tap into the larger value creation for this complex supply chain that we studied before, well, we need to study where the value is actually residing. And we realized that when we climb the ladder from materials, chemicals, wafer production into systems on chip, we see that the value creation increases. And if we then connect that to where these different things happen in the world, we see that there are some clear trends. If we study, for instance, the US and Far East, we see here in the graph that US has a very, let's say, strong position in the parts of the value chain where you add a lot of value. So when it comes to logic, so digital circuitry, etc., when it comes to EDA, core IPs, the US, they have a really strong footprint, but they're slightly weaker when it comes to equipment, materials, and so on. There we have Far East instead having a strong footprint, but Europe is somehow weak in across the line. You can see the black boxes. We have a fairly small part of the value. And in order for us to really move forward here and accelerate and invest in this game, I think it's going to be very important to consider where do we want to position ourselves in this value model? Where does it make sense for Europe to invest in order to get as much return as possible given this complex supply chain? Because it really matters if you come on top here or if you reside at the bottom when it comes to return on investment. If we go to the next slide, Patrick. So if we zoom in a little bit more, we have the same graph here, but this will just compare us a little bit to the US. So if we look at the overall percentage of the value chain, I think this was mentioned at the very beginning of the workshop as well. Europe has about 10% of this supply chain in total. But we have 20% of semiconductor consumption. So if you compare US and Europe, you see that the US, they have almost 4 times the value add in this supply chain. But we consume about the same amount of semiconductor value. So the market in Europe is quite big. It's not that far away from US, but our footprint in the ecosystem to capture value is far less. And I think this is important when we start to consider where we need to invest in order to be a really important player in this supply chain, in this value creation. Because as we have been saying in Corenect, we need to go for the complex part of this ladder. You need to be where the system on silicon is created. Like Gerhard earlier today talked about multiprocessor SoCs, where you have, the largest value creation based on the investment you provide, the microprocessors, etc. We have tremendous strengths in Europe when it comes to detailed processes and key technologies in order to make things fly. Very specific tailored technologies that we have developed over the years. But that will not really enable the biggest value creation, at least not according to our analysis in Corenect. We need to also break into the complex system on chip thinking and how that can relate to the software. So we take the next slide, Patrick. So concluding here, before I will give the word to Patrick, who will tell us how to fix all this. This is the summary slide. Basically, if we look at microelectronics in Europe today, we do have some grand challenges. One is there is no significant impact on the global software ecosystem. We don't have the muscles in Europe in our companies to do that today. It's only the big giants out there who can afford this. We're talking about Intel, NVIDIA, Qualcomm, ARM, those companies. But the microelectronic players in Europe, we have a disconnection to software ecosystem, which means that we will not be able to drive anything or, let's say, create followers. We have to comply with the rules set by the others who own these ecosystems. That is a challenge by itself. So it's very unlikely that the European microelectronic system, as we know today, will be able to disrupt anything and be able to, by themselves, just climb this ladder from the very bottom part of the value chain. That's going to be a real challenge unless we do very strategic and direct, let's say, initiatives, or take initiatives in Europe with some direct funding propositions or measures from the Commission and the private sector, of course. So this, I think, is the main bottom line, that we have some clouds on the horizon, and it's going to be a quite difficult game to play. But in Corenect, we believe there could be a recipe. So please, Patrick, enlighten us how we should take this forward.
Okay, so I will take over control again, if that's okay. So now you should see my screen.
Yes.
Okay. So thanks, Frederick, for the introduction. And now I will give you a view on how industry is looking into this. And secondly, what industry is expecting from Europe and the member states in order to build a solid plan to have a new Europe in place, so to speak. So if we look at the industry from the beginning of the years 2000, we saw a very scattered field of players with no or low profitability. We had a number of vertical players, like we had Philips, Siemens, Sony, Motorola, very broad players covering all domains from memory to processors and analog design. And most of them were loss-making. It was a very competitive business, very scattered. And so there was an evolution, and what we have seen since 2008, that there has taken place a deverticalization. So the big players have spin out their semiconductor activities. You had a number of foundries which came up, and you also have a number of strategies which went to a fabless design. And also there was also a merger and acquisition to go to a bigger scale, like you saw that TI and National went together, NXP and Freescale, and there are other examples. And also there was a big creation of focus. So it was memory business was a separate business, and others were focusing on power ICs, analog design, processing combined with analog, etc. What we see now since a couple of years is that there is a re-verticalization ongoing. If we look to Apple, Tesla, Amazon, Samsung, they are again becoming such type of big players. On the other hand, we also see that we are more and more evolving from global to local. There are trade tensions, there are pandemics, which in fact make regions aware that they should have some strategic activities within the regions. And of course, sustainability is playing a more and more important role. So now what does industry expect from governments? And then I would like to compare the different regions. Frederick already did in terms of the value of the semiconductor value chain throughout the regions. But if you look at the very high level, we see that China has a very strong ambition to become a real semiconductor leader in the world. This has even been accelerated by the trade tensions between the US and China. And they have set up what is called a big fund program, where they want to invest over 50 billions of euros in semiconductor investment. Furthermore, they are really working on long-term strategic plans, looking towards mergers and acquisitions, and they have the money to make this happen. What is also important, for example, on open source, China considers this as an industrial policy tool and an important part to push its technological autonomy. We see also that China, there is still a gap between the production and the consumption of chips. So they want to close that gap. And you see also at the bottom picture, there is an enormous investment of venture capital in Chinese IC companies. What is happening in America? In America, in 2021, almost 1 year ago, there was a cry for help from the semiconductor leaders, like, Mr. President, you need to take some action. And this action was taken because there has come up a program called Chips for America, which is also an investment of over $50 billion in the semiconductor industry in the Americas. What is happening in Europe? In Europe, there is a lot of discussion going on. There is the European Chip Act, there is the Semiconductor Industry Alliance. So the positive point is that Europe realizes the importance of the semiconductors value chain. They also found out that there is only a small global semiconductor production share left in Europe. Most of them is happening in the Far East. And what is also important is that they see the need for the development of strategic systems on chip platform design wins for key applications. So there is an awareness, there is an ambition which is stronger than ever, and what will happen now. And we also see the IPCEI program, which can make a difference. If we look from a helicopter view, and let me afford to be, I would say, somewhat cynical here, but I will show that we are working on solutions. If we look to China, we can consider them as the fast and furious, as in a movie. Everything is going very fast and they really want to be a winner. If we look to the US, they were slagging behind a bit a couple of years ago, but they clearly stated, we will be back. And when we look at Europe, we kept on dreaming of what is possible for a number of years. But now, fortunately, I see that a wake-up call has happened. They consider we are not in a movie, we have to go back to reality. And so now also in Europe, what we see is that there is a strategic element being formed. First of all, I think we all know about the semiconductor shortage has already been covered, but we also see the geopolitical reshaping, and Europe has clearly indicated the program towards industrial competitiveness, digital autonomy, sustainable Green Deal, and the European Digital Age, which can make a difference, and where it is important that the semiconductor and its value chains in the different domains of automotive industry, telecom, etc., can play a key role. So what does have to happen now? I think we have to translate the vision in Europe into a clear action plan, a clear target setting, and go for it. We see there is an investment landscape, and this is not a complete summing up of everything which is possible, but we see there are different types of programs in Europe. You have the Eureka program with XACS and ITEA, which covering mainly semiconductor hardware, software solutions. We have the Horizon Europe program. We have different initiatives in Horizon Europe, like Euro HPC, the KDT joint undertaking, SNS. And of course, we also have IPCEI, which is the largest program that we know in Europe so far. If, of course, it materializes, because it's still in negotiations. But one warning, we are still far off of the over 50 billion euro that China and the US are planning towards the semiconductor industry. But we are already in a better shape, I would say, than a couple of years ago. So we would like to ask Europe and its member states to continue this way. So what are future needs according to us in terms of EU leadership? For economic and sustainable sovereignty and resilience, we have to create and streamline some concrete actions for market growth through our technological excellence. We are excellent in a number of domains. Let's please keep this technological excellence and build it further on. We also need to ensure a level playing field of Europe with the US and China, and also within the different member states of the European Union. And so the member states and Europe should act with one voice and make sure that we are competitive compared to the other continents in the world. Sometimes there are discussions about the value chains, or we call it often the value networks, because we don't consider it a classical chain anymore, but really a network of players working together. And sometimes people say we need to have the whole value chain in Europe. We do not agree on that. I think it's more important to have control over a number of critical parts, strategic elements in the value chain, which we need to keep in Europe. Furthermore, we have to streamline the strategic priorities between the EU, the member states, and the industry. I think there is enough critical mass for a number of top priority ambitions, and IPCEI 2 on microelectronics is an ideal platform in order to realize this. We also have to look to stimulate joint strategic developments amongst semiconductor companies. For example, I talked already about the importance of open source hardware in China. We need to work on this in Europe, for example, by the Airbus of RISC-V, and also between OEMs and semiconductor companies to develop jointly activities together. And finally, we need to work both on vertical alliances and horizontal competence areas and allow for fast-track initiatives for smaller scale key technological advancements in specific areas. So what is the conclusion? I think we should not focus only on getting the most advanced production nodes in Europe. I think we have excellent players in terms of equipment, and they should remain a #1 position. But that does not mean that we should have this advanced processing nodes already from tomorrow onwards in Europe. This is much longer term, but we need to work on specialized flexible manufacturing nodes, dedicated technologies, gallium nitride, SOI, smart CMOS, including analog design and covering 10 to 180 nanometer type of designs. We need to work on leading edge processor and domain specific high-end SoC platform designs. It's easily 100 to 200 million euro investment if you build a real processor or a real SoC platform design for a strategic domain. And we should focus on the domains where Europe is strong in, and we also should work further on RISC-V and open source hardware and software as a driver to develop these future platforms. And a working group in Europe has already calculated that this also can mount to a 1 billion euro investment. So I would say we have started a good path. Let's go on with it, and then let's make sure that we are winning in the domains we would like to win. And that's it from my side. So we're open for any questions.
Thank you, Patrick and Frederick. Now we have some questions from the audience. Frank Hoffman is asking, do you see the chance to build up a new European player on global scale?
And what is a global player? I mean, I see in Europe a lot of startups. And of course, then the question is what happens with these startups? Some have a longer lifetime, some grow big, and yeah, some are taken over by large industrial players.
I think
to have a real new player like a new Samsung or a new Intel in Europe, I think that's a dream too far, so to speak.
Yeah, and this is a great introduction to the presentation I will give just after you.
Okay, excellent, Jacques.
Okay, if there's no further question, I have one question.
I think Frederick is saying something, but he's again on mute, I'm afraid.
No, I'm unmuted. Thank you. So I think in order to grow a global player, let's say the one Patrick referred to as a new Qualcomm or Intel or anything like that, you need to have the right prerequisites, the right ecosystem where you grow that player. Because you need to recruit so many talents, you need to recruit so many side functions. So in order for that to happen, Europe must really position itself to be one of the most attractive, let's say, regions in the world for that particular business such a player would target. That's a prerequisite, I would say. So you can have enough engineering brains in the ecosystem that will support you to be the most innovative player, capture the most benefits out there, and have a, let's say, a superior product portfolio down the road. And that's going to be a challenge, I think. But it can, if it can be done in other places in the world, of course, it can be done in Europe. I mean, it's nothing impossible. It's that we need to have the right prerequisites in place for it.
Yeah, if you look at some years ago, I remember in the 90s, ARM started as a startup and has now become a world player in the field. So these things are possible.
Okay, thank you, Patrick. Frederick, I have another question because I think at the moment, I think it's also mentioned in the morning that if we see there's lots of program on the research and the innovation, Europe is actually very strong in the research still. So how can we assure that this research and innovation development, all the investment we have there, will in the end transfer to really market or product success, commercial success? because this is the point. If I see that it's a really there's a gap there in Europe at the moment. So what do you see would be the most important factor to do that, to ensure this will be a smooth transition there?
That's a tough question. Of course, if there was an easy recipe, everyone would, of course, employ such a recipe, because it's not only a challenge in Europe. This goes across the globe. I think, how do you actually capitalize on your investments? And we are investing a lot in R&D or research, investing in young people to educate themselves here in Europe, and we have very strong educational programs in our universities. So how do we capitalize on that down the road? Well, you must have employees who can, or employers, sorry, who can embrace those smart people once they graduate, once they're ready to sort of embark on their business careers. How do you manage to capture that? Yeah, that's a good question. You must have a healthy ecosystem, that starting point. I think if you have that in place, then it's downhill. Then you don't need to worry that much, but you need to have something like a Silicon Valley in place. You need to have a lot of startups happening, a lot of vitalization that can absorb these talents, and then you will have success stories based on that, and you will see companies grow, etc. And of course, there will be big players around as well. So it's all about creating the ecosystem. I think if we manage to get business back to Europe in a way that we can sort of create enough value in the value chain we talked about, not only do components that are vital to the value chain, but actually do components that bring a lot of value in the value chain, then I think we're onto something. I think Europe, we're excellent in doing vital pieces, maybe small components who are absolutely vital for a certain product. But what those components will do is that they will enable other ecosystems to maybe take advantage of the larger value creation. We must be better at also sort of zoom in on the larger pieces of the value chain, not only the narrow segments or very super specialized segments. I think that would be my 5 cents. But please, Patrick.
I agree, Frederick, with what you say, and on the other hand, I would also like to add that sometimes in Europe we are too modest. We can give some examples, like for example in automotive electronics, 3 European players are in the top 5 of automotive semiconductor market. If you look in equipment, ASML is the undisputed #1 in semiconductor equipment. There are other examples like that. And in addition, I think we also have a different landscape in Europe, which consists of a lot of SMEs, startup companies from universities who do excellent business, but which of course are not always as visible as the big players that come on the marketplace. But I think Jacques can again give much more information on that last one.
Okay, so thank you, Frederick and Patrick, for excellent presentation, and that was very inspiring. And now we come to we have lots of discussion already about SME. So now we have Jack Megan from Astrulo to talk about SME in this ecosystem and his initial recommendations. He is a senior project manager at Astrulo. He chairs NetworldEurope SME Working Group and is a member of Europe Steering Board. He also represents Astrulo in the 6G Infrastructure Association and serves as a board member of 5GIA from 2016 to 2020. So now, Jack, the stage is yours.
Thank you very much, Yanning. And as I was just saying, I think that the discussion that we just had is a very good introduction to this presentation. So basically, I am going to focus on SMEs in this ecosystem at the crossroad of microelectronics and connectivity. And we have worked in Corenect already at trying to understand what kind of position those SMEs could have in this ecosystem, and try to come out with some preliminary recommendations. And it's really, really important that I try to summarize briefly those recommendations today, because I hope we are going to get feedback from the participants and it will be discussed during the panel. So this presentation is going to very briefly give a reminder of the Corenect ecosystem, or rather ecosystems with an S. Then trying to see how we can position those SMEs in these ecosystems, then assess the opportunities and challenges that are there for SMEs. Actually, some of them have already been discussed in the previous presentations. And I will finish with a few initial recommendations. So, I mean, don't be afraid by these very complicated diagram. What is important is that when we are talking about the Corenect ecosystem, as the title of this workshop is about, we are at the crossroad of microelectronics and connectivity. So this is really what we are looking at. But there are actually two angles or two aspects that we can look at in terms of ecosystem. On the left-hand side, there is what we call the Corenect community, the provisioning ecosystem. That is all the organization that will play a role in developing technologies for microelectronics and connectivity. But then there is also another ecosystem, which is represented on this slide on the right-hand side, which is the use case ecosystem, the users of the technologies. And this is primarily all the players that play a role in the different vertical sectors. I mean, we had a presentation on media, we discussed a lot about automotive or Industry 4.0, and all these players need to be considered as well, because they can have also an added value in the overall chain. So when we look at SMEs, the first thing in these particular ecosystems, where are the SMEs? And what I have perceived in the past few years is that when we look at the 5G, 6G ecosystem, there is a kind of a tendency to primarily position SMEs as technology users rather than technology providers. However, when we look at the SME participation in the 5G public-private partnership, actually this tendency cannot be, we cannot conclude that this tendency is actually correct. I mean, there are SMEs, of course, participating as technology users, but there are also many SMEs participating in the projects as technology providers. Then when we look at the ECS ecosystem, I would say it's a little bit the same story. When we look, for example, at the member states' European Initiative on Processors and Semiconductor Technologies, when we look into the text, they seem also to position SMEs more as technology users. However, when we look into the research projects from, for example, Excel, Penta, Katrine before, and so on and so forth, then we see many SMEs who are positioning themselves as technology providers. So basically, from the Corenect perspective, it's quite difficult to draw any conclusion at this stage whether, you know, SMEs are on the one hand or on the other hand of the ecosystem. So we shall consider them, SMEs, as potential contributors in both the technology and the user ecosystems. So what are the opportunities and challenges for SMEs? And some of them have already been discussed again. So there are many people who are convinced that there will be opportunities for SMEs with the deployment of 5G and the advent of 6G. So many people think that SMEs will participate more actively in the near future in the entire communications ecosystem, and especially by contributing to 5G-based application and technologies that will support the telecom networks rollout. Especially because some people are convinced that the operators, both the European and Americans, are going to look for diversification of their solution somewhat. And when we had actually a Corenect public consultation, and this highlighted the opportunity for SMEs, for example, to target a particular part of the technology or a specific part of the market value chain, but also to validate forward-looking innovative advanced products and cooperate with academic institutions for the implementation of technology at early stage. However, of course, there are still challenges, and some of them have been mentioned. For example, the dependence on large-scale trial or pre-commercial infrastructures when it comes to testing on a large scale the products that are developed in SME. The heavy investment that is required not only for developing chips, but also, for example, for contributing to standardization and all the issues related to IPR and patents. And also the fact that the telecom market is still quite fragmented in Europe, and that makes it more challenging for SMEs to broaden the market even within the European Union. So one of the Corenect's objective, and this is where I come back to the question raised by Frank Hoffman, was to create the conditions for one or more European champion in the domain that we are talking about. So we are convinced that there is room in the next 10 years for the emergence of European champions in the microelectronics and connectivity domain. However, we are not making any, I would say, specific assumption as to what forms such champions will take. It could be indeed startups, it could be spin-off, but it could also be joint ventures or a new branch of an existing large company or an SME. So this could actually prove to be either an opportunity or a challenge for SMEs. So in terms of initial recommendations, so we have divided that into 3 categories. One is recommendations that would promote the role of the SMEs in the ecosystem, then recommendations that are really focusing only on SMEs, and then some general recommendations that are also applicable to SMEs. So in terms of promoting the role of SMEs in the ecosystem, we think that we need to strengthen the interaction between corporate companies, research organizations, and SME, with the main objective of gathering the best in the field, and therefore ensure that Europe is going to be at the edge of components for 6G. And to do that, we need to enable as much as possible the matchmaking between European SMEs and between SMEs and other European stakeholders. But that should cover not only R&D and technology and innovation, but also education, finance, and funding. And it should not go only towards startups, but also to spin-offs and established SMEs, because there is a kind of a thinking that everything shall go to startups. We think it's not the case. And the main objective here, of course, is to overcome this issue that was just discussed of Europe not succeeding in creating companies worth hundreds of billions of euros, like what is being achieved, especially in the US and China. So another recommendation would be to focus on existing European strength, for example, industrial applications. But basically, if I make it short, we need to try to help create a community European ecosystem combining microelectronics and connectivity that would be able to compete at global level. And if we have one or more European champion, then they could lead the way to create these ecosystems. If we look for recommendations only for SMEs, we could indeed dedicate specific envelopes within Horizon Europe for SMEs working on components for connectivity system. So that could be, for example, and I think if I'm not mistaken, that was mentioned this morning by Mario in the first presentation, where a joint effort between the 2 partnerships, the one on telecom, the SNS, and the one in microelectronics, KDT. But we also need to encourage corporate participation in targeted investments in VC funds that would finance early stage SME, of course, that would be developing advanced connectivity applications. And it's not only the microelectronics and the telecoms corporate that should be involved, and in the telecom, of course, both the equipment manufacturers and the telco, but also the vertical corporates, because they will be the one benefiting from European-based components systems. We could create a dedicated co-investment platform focusing specifically on components for 6G, or create pan-European sandboxes that are one-stop shops where a company would apply and would be automatically eligible to offer products and services throughout the EU market. When we look at general recommendations, promote international standardization for 5G and 6G as a means to open the supply market landscape to smaller hardware and solution providers or startups, and also promote the diversity of players in the 5G supply market. Maybe supporting an EU open source computing hardware, especially to lower the entry cost for new chip designs. Establish a clear link, I think this is really important, between the overall EU industrial strategy and the activities of the SNS and KDT partnerships, because that would lead to more technological sovereignty in the domain of components for 6G. And then we could think also, as the European Parliament member said, spread innovation beyond Horizon Europe. Let's not look only at what is being done in Horizon Europe and in research and innovation. We can look at regional policy. We can look at what is being done in agriculture in such structural form. So let's try to broaden a little bit our landscape. So I want to thank you for this, and your feedback, of course, is more than welcome. And I must say that I am expecting a lot from the panel that is going to come afterwards, and especially I'd like to know what you think of those initial recommendations of the possible position or positioning of the SMEs in the microelectronics and connectivity domain. Thank you so much.
Thank you, Jack, for excellent presentations and all the recommendations to SMEs. And I think it is open lots of questions and be used for the panel later. So before that, I will ask any question for the audiences. Okay, maybe I have one question to start with. So as we have discussed that, in this components, microelectronics, or even 6G, 5G, it is a very tough market. It's very difficult to build anything from scratch. And also you mentioned that there's a many different form of create European champions, right? I'm just wondering, because as mentioned by Gerhard this morning, it's about acquisition of small SMEs. So do you think it will be also a great opportunity to SMEs and for the European strategy that if we can encourage European companies to buy European SMEs?
Well, from an SME perspective, I cannot say I like very much your idea, okay? Mm-hmm. Personally, but I hope this type of thing is going to be discussed in the panel. So I'm just going to give you my view. I would believe more in trying to establish better partnerships amongst SMEs along the value chain. Okay, so I'm not saying that SMEs need to do everything on their own and exclude large companies. I believe there is a need also for partnerships and interaction between SMEs and large companies. But I think there are alternate possibilities, alternate options, and probably the partnership between SMEs is an option that has not been investigated enough. At least this is, again, my personal view.
Okay, thank you, Jack. And so if you don't have, if no any further question, I think it's time to go to the final part of our workshop. So we have heard so many discussion about ecosystem, European strategy, education, what should we do, SME. So now we come to the last panel session, which is a conclusion of the, today's workshop. Now I hand over this to the moderator of this panel, Gerhard. So Gerhard, yes. So please take from there.
So I first of all want to welcome everybody here. I want to make sure that we can introduce everybody on the panel. Let's see if everybody's there. Yes, I see Frank, I see Mohand, I see Bernard, I see Werner, and I see. What's happening here? I don't see everybody. Sorry, everybody, but things are moving slowly. 1, 2, 3, 4, 5, 6, 7. I see we have the panel ready. I want to make sure that we really welcome everybody here from the panel. We know this is really an important topic. We heard more about the panel happening today already, and it's a challenge for all of Europe. With this, basically, we have to make sure that we understand that we have to discuss a couple main topics. How do we position Europe in this, let's say, situation, which is certainly more than challenging? From a perspective point of view, therefore, I would like to ask every one of the panelists. We have Kari, we have Blanca, we have Kari, sorry, we have Bernard, we have Frank Hoffmann, we have Mohand, we have Frederick, and we have, let me check the last, Monsieur, sorry, I don't see your name in the slide deck here. We have, with this, I would like to now go and say, can we please have everybody give us a brief introduction of 2 minutes where you think we really need to do something? Because from your perspective, where are the major challenges of Europe when we're facing microelectronics, certainly in the connectivity domain? And what are the major actions that we really should have? I would like everyone just to give a brief 2-minute statement, if possible, without slides. And certainly we will all be here to take notes, and off we go. Maybe we start with Bosch, Frank Hoffmann.
So I hope you can hear me.
Yes, we can.
Fine. So maybe let's start. What is the perspective, what we see? I would like to start with some words about the position of Bosch in the ecosystem of microelectronics and connectivity. Because Bosch is, on the one side, an interesting position with many perspectives as a vertical player, but we are also engaged here in automotive, in industry, in home appliances as a vertical player. But on the other side, Bosch is also a semiconductor company with own plants, but we also buy the majority of our semiconductors which we need for our products. Looking at Europe, I want to direct a few to the two major strong industries, the automotive industry and the factory automation. I think about the automotive industry, we heard already quite a lot today, but also factory automation is very important for us. And both industries rely more and more on connectivity, and both industries need complex platform chips, automotive grade or industry grade chips respectively. But the variety of 5G terminal chips is very limited currently. As you know, the market players are from the US and Asia, and we also heard that they dominate the market. And what should Europe take action for it? I do not want to list now all the actions what we already heard and which came up to my mind. I want to concentrate on one particular topic here. Marco Ceccarelli in the morning from DG Connect showed that EU was late in 5G standardization, and this was also a disadvantage for microelectronic development in Europe. Often the main focus in the EU is on cellular networks, which is also important, but from my point of view, also equipment side plays a comparable important role if we think about the vertical industries. And the EU should spend more effort to platform chips for these vertical industries because they play an essential role for these industries. And the connected platform chips with integrated AI are getting more and more important and to be the brain of these intelligent industry devices. And as we currently already see, and it was also demonstrated, for example, for automated and connected vehicles. And I think Europe should take care to build up players able to develop such complex platform chips.
Thank you. Now let's move on from an application to a semiconductor. Frederick, maybe you can give us your view your two notes from ST point of view or your personal view.
I think I'm pretty in line with what has just been said, and it echoes what has been said by Frederick and Patrick. So basically, when we look at history in Europe, we are strong in verticals where we do have, let's say, system player in Europe. And then on those fields, we can leverage and bring value to our customer, developing differentiated technologies with manufacturing capability in Europe. So this is basically what we did for industrial and for automotive. And now the question is, can we make sure that we remain strong in those areas, and can we leverage and capture other opportunities? And basically, it's going in the same direction as what Bosch said. At some point, we need to have, let's say, system-level player setting the direction in order to make sure that we have a full ecosystem. I don't think it can be a technology push discussion. And that's one of the main challenges today. It's not just semiconductor manufacturing alone.
Thank you, Frederick. Mohand. Now we go to the third domain, meaning the equipment manufacturer, Nokia.
So thank you. From my view, to start with this panel, I would like just to remind everyone that during the past 10 years, we have seen a major shift in the connectivity business. So many of traditionally companies have sourced their CPUs and other chips to companies like Intel. But today, even the companies that are involved in mobile device production, they are building their own chips. So this, of course, for many reasons, one of the big reasons is that they can, of course, improve the power consumption. They could also reduce the cost. They could also ensure a better security. And of course, there is also some, they could improve also the futures of those chips. One of the other observations that we could see is that we see moving to the cloud. And on that respect, there is, of course, in the previous challenge, companies had to adapt, and in particular the telecom equipment manufacturers. And we see in Europe that we are starting to adapt on that respect. We saw also in the different presentations that there are some support from the European Union and the member state in order to increase, let's say, what we call the sovereignty now. But the moving to the cloud is facing us to a major challenge, which is the competition with the big players like the web scarce companies that have the capital in order to invest in this new chips technologies. And in my view, and in the view of many people, that this will be the major challenge that we will be facing in the next years. So this is my introduction, Gard.
Très bien, Mohan. So now if we go now to a smaller player, then I would like to ask Benoit to give us, how do you pronounce it? Kalray?
Yes, so just a short words from Kalray direct experience with some of the issue. So I would say about the major challenge in microelectronics is that we don't have the basic components of the platform chips that Frank from Bosch mentioned. It starts with the GPP, but the GPP we could have in Europe based on RISC-V, it's very weak. We have the Noel 5 and we have the Ariane, known as the CVS6 from Open Hardware Group. And they are the two capable of running Linux, but they are not powerful. And then we need the GPGPU and the others, the FPGA and the connectivity components. So I would say that would be the major challenges. with regard to the action, maybe do like in China. First, when you have components to go in critical infrastructure, in aerospace, in telecom, mandate that the IP is of EU origin. In fact, now in China, we had Chinese investors, but at one point we couldn't supply to them anymore because they were entering aerospace. So maybe those rules, they are very heavy-handed rules, but maybe they have a role to play. And then maybe the big company should have incentive to, instead of doing in-house R&D, maybe tax intensive to try at least SMEs and startup technology. Even if it doesn't fit, it will create a flow of ideas or ID for new innovation, and for the SMEs would be more contact and more cushioning against a direct competition from established companies in the US and China. So those recommendations, they are more like a big control, but I think at the point we are now, maybe they are necessary for a limited amount of time.
Great. Now, after listening to this, Werner, you have worked for one of the dominant semiconductor players in the world, and now you are one of the smallest players in the world. So you worked on both sides.
Yeah, so I started on semiconductor and now I'm on the software side. The topic is communications and microelectronics, but I really feel more comfortable talking about microelectronics as I have more hands-on experience there. And I would argue the biggest challenge that we have is closing the gap in building the highly complex digital systems. And that's what pretty much everybody said in various forms today. We are excellent here in Europe in providing building blocks, whether it's analog components or specialized microcontrollers, but I doubt that we could develop an SoC that could compete, for example, with the high-end products from Apple, Samsung, Qualcomm that go into that domain. And this effectively limits our ability to truly innovate on system level. And I'd like us to, here in Europe, to come up with truly innovative ideas where we say, well, somebody mentioned non-volatile memory before. What if we had a computer that was built on the premise of having non-volatile memory only, where you don't have this boot procedure where you load something from disk into memory? This could revolutionize, at least in my mind, the whole factory automation thing, because you don't have to power up things. They are just always online. And with respect to how to support that on a European level, I'd like to see a more concerted effort, similar to the way, well, DARPA, they said, we want to have an autonomous driving vehicle somewhere out in the desert, finding the way from A to B. And that's the kind of focus that I'd like to have here on the research side, not just doing the research and getting money out to SMEs and the bigger companies, but have a clearly defined goal. And we had that in Europe in the past. Before we had the space launchers with Arianespace, highly successful. Some politicians decided a couple decades ago, well, let's put commercial aircraft in the air that are built in Europe. If we could come up with something similar for the comms business, that would be my dream scenario.
Great. And before I let Bernard speak, I want to read a little bit of a text that I have here as an intro for our discussion. And Bernard, you're the bridge between my little intro and the discussion. So think of it. 1450, Europe invented print. The invention of mass communication it was, and it started an unprecedented growth and stream of democratization, innovation, and freedom of knowledge. 300 years of first Renaissance. 1898, again, Europe invented digital print, the World Wide Web. And this basically sets off the disruption that we're in today, right? Today, we're living a little more than 30 years thereafter, and we're living at the beginning of a second Renaissance, the complete digitization of our world in a different way. that we talk about, but what it is really is the second Renaissance. And that's creating all the turmoil that we have seen at that time. We had Savonarola being taking down the Medici. We had wars, 30-year war in Germany. We had terrible times, but also great times, because I mean, the democratization of knowledge and the freedom of slavery. 99% of people in Germany, for example, were slaves before the invention of analog print. So now we're seeing a similar wake up in the whole world. And connectivity and microelectronics are the twin foundations, so connectivity and microelectronics, for this whole new reality, supporting transport, store, and processing of data, supporting our digital sovereignty, economy, and society. Or if we're not there and we don't have somehow a handle on connectivity and microelectronics, we lose it. So where is Europe's leadership role today? We have chipset shortage. We have lack of knowledge on processors, cloud, chipset platforms, web scale industry. And with the trend of ORAN, will Europe finally end its lead or lose its pole position in cellular? Because everything is going to be based on platform chips. Will Europe unavoidably face great challenges within connectivity and microelectronics in the next years, which basically will impact our pace for digitization and therefore completely lose out as Europe and just being in the watching the rest of the world move on? And this means not only industry leadership, but even national security. So we need to wake up. And we heard some first introductions from 3 industry stakeholders of microelectronics and connectivity enabled verticals. ST, we have Nokia, and we have Bosch. And one representative of the Finnish government, Kari, we still have to hear him, and the European Union. So Kari, you first, from a government point of view, to make your opening statement. Now also, after I sort of let the first guys give some first impression, I put this in a dramatic big picture, and you from the Finnish side say something, and then we have Bernard, and then we
okay. I'm tempted by your introductory or the printing idea, but I still present the views that we have on these first questions, the challenges, and I'll bring up a new challenge that I haven't heard today yet, and not at least as much as I'm trying to tell you about it, and that's the shortage of people that actually can do the design, the electronics, the radio frequency designs, the hardware. An example is a university town here in Finland that has counted how many of the leading RF radio frequency designers working in that city, how many of them will be retired, enjoy their well-earned pension in 5 to 10 years, and that's far more than the number of people, new students that will come in to do the designs. And we've seen the indications elsewhere in Europe quite similar, that within 5 to 10 years we need to have more people here, and the problem is that the industry is not really tempting. It's not challenging the young brains to come and work for the industry, and that's something that we can't do by governmental rules or decisions or whatever. This has to come from the industry, that new people join. And the other problem that we are facing is actually the high costs of setting up any kind of semiconductor manufacturing. It is a high threshold for small companies to start building, start producing something, and that's also something that should be solved within the European level. We've seen a lot of promising new and older SMEs and startups that after they get a patent for their first innovation and they show that the product works, they get acquired by often Asian companies that then make business out of these components, and we just don't have the investment here, not here in Finland, not here in Europe, that would allow these companies to start manufacturing their new products here. And that's something that also we would like to be resolved. Thank you, and thank you, by the way. This has been so far really a good talk all day through. Sorry, I spoiled it. But anyway, over to you. Thank you.
Thank you, Kari. Then I come to Bernard. You might want to give your or the European Union's, the Commission's view.
Yeah.
Whichever point you want to make.
Thanks a lot, Gerhard. You can hear me, or is it working?
Fantastic. We hear you very well.
Okay, super. So first of all, many thanks for having me today with you. You may remember that in my unit, we originated this Corenect project more than 3 years ago with my colleague Mario Cilia, who is also attending today. And our intention in those days, we didn't have IPCI, we didn't have Commissioner Breton, we didn't have CHIPAX, we didn't have all that. But we, from the 5G experience, already noted that we should do much more in microelectronics in those days. And one of the very first challenge that we could see was to bring together the microelectronics people and the telecom people, which we tried to do at the beginning of the 5G PPP in 2013. And I must say we failed miserably because we didn't have the response we wanted to have at least from the large microelectronics companies, even though we had a little bit of response from let's say, research centers like Leti or IMEC or Fraunhofer, of course. Now, it seems that these days, this business is coming much more prominently because we have seen with 5G developments that microelectronics becomes really a critical element in the overall chain. And what we are trying to do for the future, this is what we believe in and what was alluded to by previous speakers, is to have a more value chain encompassing approach. We have, at this moment in time, strongholds in connectivity, not so much strongholds in devices, as it was said in the previous speeches. But we have a belief that if everything is going to be connected, and cars was the kind of elephant in the room today, but there are many more things which will be connected, drones, cranes, robots, whatever you name it. There is a potential market for devices and terminals, which potentially will drive the platforms that you were mentioning in such a way that we can possibly establish the linkages or the partnerships within industry to have this value chain approach that at the end of the day may deliver the components or the component capabilities that we need to have a more encompassing capabilities in this particular domain. I take the point of Cyberus when you say I don't see the project, the automated car that is pushed by DARPA and put it to work, and this is going to leverage technological developments. I mean, 6G is our technology, is our connected car. 6G is our end product today that we have an opportunity over the couple of years to take as a platform to develop the technology among the players. We need, in our view, to, of course, this is all framed by the $50 billion that was mentioned by Patrick and Frederick in their presentation, which China is doing, which US is doing as well. But we have not yet seen the CHIP Act. In the CHIP Act, once it is going to be published, there should be some answers along that line. So I'm not saying that money is not the problem, far from it, but I believe that with the design or the engineering of the CHIP Act that was presented by Marco this morning, there will be some elements of response to these investment capabilities and investment needs. In 6G, we have a lot of investments today in Europe. We are going to put 900 millions on the table, but Germany is putting 700 millions, Finland 250 millions, Spain 100 millions, I mean France 450 millions. I mean, there are a lot of budgets which are, let's say, being put on the table. And what we would like to do is to create as much value out of this money as possible. And that's one of the reasons for the 6G program. We will try to have a much stronger synergies with what is happening in the member states in such a way that we can really streamline or improve the directivity of our joint investments. Now, one very last point, you talked about ORAN, Open RAN, which is not ORAN, as Benoit said. This trend in the network, we see it very much happening. We still have a lot of questions about this trend because, first of all, it's a subject which is very much loaded with politics. So there are a lot of, let's say, industrial policy initiatives behind this, and this is many times marketed as a vendor diversity tool. We don't see it necessarily as a vendor diversity tool, but if it can be a vehicle for diversity at the level of the components, this is something that we would very much like. The problem is that when we look at it from a vendor diversity point of view at the chipset level, at the components level, which today I suppose all the ORAN implementations are mostly based on FlexRAN, which was presented or alluded to before by one of the speakers. The people are moving into this domain. They have already large market shares through their positions in the device markets or through their position in the data center market. We don't have that position in Europe, and the markets of 5G base stations, 6G base stations, they are no way comparable with the markets of smartphone or the markets, the huge volumes that you have in devices. So my perspective, but this is a question mark which is put to the question to the Corenet people, is that if we want to regain ground in this domain, we need to create the conditions for an ecosystem which is large volume in such a way that what is being discussed in the context of large volume markets can be further exploited in domains where there is less volume, such as the connectivity infrastructure. And this is where we are trying to see what can be possible. And of course, the Corenet reflections are extremely helpful for us to guide us. So a few introductory statements.
Great, thank you. Now we have had a couple interesting statements, and if we look at it, I tried to sort of capture a little bit of it, what has been said.
You're muted.
Yeah, we cannot hear you.
Oh, sorry. I thought I'm unmuted and I've actually muted. Sorry. So if we put this whole thing together, now we hear these interesting statements. We see that we have the statement that we need manufacturing. And manufacturing is fairly cheap. Cost 100 billion. In the days of COVID budgets, we have been spending way more than that, much faster than you can spend the money on building the biggest semiconductor cluster on planet Earth. So I think this is all doable. The second thing we heard from others is that we need platform chips. The product manufacturing side alone is not really what we're talking about, product chips. And then we have a couple issues. We have issues we don't have people that can design. We heard that. We heard that there's no market pull. There's no true market. And we heard that there are existing players and we need to come up with new ideas. Yes, if I sort of capture what Frank, Frederick, Mohan, Benoit, Werner, and Kari and Bernard said, this is more or less one way of sort of summarizing this. And so we need to find an edge where we can sort of break into the market. And Bernard said, you just said 6G is it. Now, as we all know, 6G is from 50 bits per second to 50 gigabit per second. So it is not one kind of solution that fits all, but it's a whole Okay. And that will be available and addressable in one standard. So my question is now, if we think of how to bootstrap a market, because in the end, who cares about production sites? If we don't have local customers that actually buy these chips, and we don't have them, as I always mention, I mean, if we take current days market situation and we were to build here a leading edge fab, it would start producing chips in January, and by mid-February, latest, it will be done with producing all the chips Europe needs, and after that, it can only sell them outside. So we need to make sure that we can build some kind of a bootstrap market so we have a competitive edge against other countries, other regions that serve the international market already in a very competitive way. Where do you think, is it really the 6G, but 6G is at the infrastructure side or is it the terminal side? Or what part of the 6G could it be for us to come up with really the system on chip platforms, chips that we need, such that the whole software ecosphere can be built on top, value chain can be built on top, and we can also, below the design of the chip, also start filling the fabs. Does anybody want to go forward on that question? Yes, Bosch. Frank first.
Maybe first one remark from my side. I was a little surprised about to hear that we have no customers here in Europe. Maybe for the consumer electronics, I think this could be the case because this is mainly focused on smartphones. But if we look, what we have seen today quite a lot is on automotive market. And if we look at manufacturing sites, then I see here a quite huge market and two industry where Europe is very strong in, and where we see also the need for future platforms here. That I think would be one remark from my side. And the other one is about 6G. 6G is not clearly defined for us up to now. I think we're still struggling a little what will be 6G in detail, and that's very important to find out, and the discussions are very good to it. Nevertheless, if you look for standardization, then we typically look at release to the next release to the next release, and it's not that we should wait for 6G and say then everything will be good. I think we can also start with quite earlier, because what we learned, for example, with one example would be this integrated communication and sensing, which is one important topic for us, for example. And this was a clearly defined 6G topic. But now we learned that the discussions are already ongoing to implement this integrated communication and sensing already in 5G release 19. So it's coming much earlier than expected and will be maybe, it's not defined up to now, but a 5G technology. So here we have also to be a little careful that it's not 5G and then comes 6G. From our perspective, it's more step-by-step approach, and here we have to find the right entrance.
Okay, Bernard, you raised your hand before we go
Yes,
back.
thank you very much. Just one comment on what was said. I mean, release 19, I don't know, because the 3GPP just defined release 18. So I think if there are, they have just dried the ink of release 18 specifications. So they will have about 2 years now to work on release 18, and we will see what release 19 will incorporate. But it's not before 1 year time, then this is going to be discussed. So I don't know exactly if this is really going to happen release 19 or not. In terms of markets, there is a market which, in our view, can also catalyze a lot of public attention and a lot of public support, which is the healthcare market. I think it's a domain which has not been very much, let's say, targeted so far, but this is a very important, also from a public policy perspective, it's a very, very important market. Today, we have Industry Association for Automotive, IGAA, we have Industry Association for Industry 4.0, 5G Asia, but there is not much on healthcare, and this is a domain which could potentially deliver large volumes of devices. We see it already today that there are a lot of devices which are being put on the market to control your glycemia if you are suffering from diabetes or whatever. Everything comes from the US. Brands like Abbott, Medtronic, a few developments in Europe, but not that much. But this type of connected device, we believe, is bound to expand. And this is certainly a domain where the public sector could get mobilized with a very clear interest from the population and clear support, rather than hearing from the population that 5G radiates all sort of nasty radiations into the brain of people. And coming back from the perspective of designing components or designing chipsets, it seems to us, but again, it's only a feeling on our side, and the experts like you are should tell us yes or no, or you are right or you are completely wrong, is that one of the requirements that we see coming in connectivity infrastructures, but also to the connected device that will be there, because it will be connected cars, critical stuff, robots, is the security dimension. And we believe that security as a design driver is bound to become much, much higher in terms of importance. We see the success of ARM is done on energy efficiency. Probably the success of Intel is done on performance. That I would need your let's say your judgment on that. I'm not really an expert. But it seems to me that in the future, everything that comes with the security strings attached and with security certified characteristics would potentially have the possibility to get traction in the market, because all these connected things, be they in B2B, they will be much more critical than connecting a smartphone. I mean, you don't want your connected car to run in the first bus shelter, or you don't want your factory to stop whenever there is a hiccup, or you don't want your healthcare device to send whatever kind of wrong information if not in the right coverage. So this would be a little bit our perspective to see if we can develop something from the creation of ecosystem, because this word was used several times by several players. I think it's important that we have a strategy to create an ecosystem. This is something that we suffered, for instance, in 3G. In 3G, we developed a network technology, and then we had to wait for Apple to put their terminals on the market to make it take up. And if we don't have this integrated perspective of moving into 6G with, at the same time, the perspective of creating the ecosystem that is going to leverage this technology, we will not be in a good position. And that's the reason why in our, I would say, modest program, compared to the investments in microelectronics which are required, but in our modest SNS program, we try to associate the vertical industries from the onset, and not as we did for the 5G PPP, but now we try to have a much more integrated approach between the potential ecosystem drivers and the technology suppliers. So just a few remarks on my side for this question that you asked.
Thanks, Bernard. Werner, you have your hand raised. Sorry, but everybody that wants to speak, please do it like Werner. Just raise your hand until it's your turn. Or
okay, thank you, Gerhard.
Yeah, how else to do it with WebEx?
I'd like to comment on this market pull thingy, and then follow up on some of the things that were just said. When Steve Jobs put up the first iPhone, there was no market pull for an iPhone yet, because nobody had seen it before. And I think we are in a similar position here with 6G, and whether it's 5G, 6G, it doesn't matter to me. To me, what is important, we will have a lot more connected devices, and that's the true differentiator. And we should come up with innovative solutions to handle that. And when we look at this healthcare stuff that was just mentioned, I am afraid that we just follow what the Americans would like to do. They have their Qualcomms, they have their Intels, they can put two chips together, they put out a nice heartbeat monitoring device and sell it as God's gift to healthcare monitoring, whatever. that's not what I like to see. What I like to see from Europe is to come up with truly innovative architectures where we say, okay, security so far has been an afterthought, and we just put it on when something got broken and some cyber attacks happened. Well, let's start with an architecture, with devices, with processor architecture that is taking into account this whole connected infrastructure right from the beginning, and do that. And I'm pretty sure that the rest of the world will follow if we come up with a compelling user experience like what Steve Jobs did, because he showed that with a swipe of his fingers is just a lot easier than if you have to type things. And I think that's the way we have to go there. And since 6G is still out in the future, that's the opportunity for Europe to really play to our strengths instead of just taking something that has been developed somewhere else and trying to make it more energy efficient, whatever different form factors. No, we should come up with new ideas, what we can do with our technology here. And if we are good enough, the rest of the world will follow. I'm pretty sure about that.
Okay, so I like that angle with the security. I would build it even bigger. I would name it trustworthiness, saying that security is one component within that. But if we were really to build a chip platform with operating system and software stack on top and the semiconductor manufacturing process below, such that we know this is a trustworthy component, and it's not combining, as I mentioned this morning, the identity of one person with the location of the same person with all kinds of other features of the same person. Then, because it will only do this for services that officially have that authority to be able to do that, then we would have already a complete different level of trustworthiness than we have today. And of course, it goes on such that if we think it through, we have to make sure that the operating system, the processor that interfaces with the operating system, the semiconductor platform, everything has to have that kind of a capability. If we were then to take that and put this in with Bernard's idea and saying, how about health and fitness? I mean, everybody has these fitness watches, and people are becoming more and more absurdly observing about their own state of fitness. Is that something that you could see? Maybe Kari, you coming from the Finnish mindset, that you see that for that would be a possibility. Maybe ST, from the possibility of understanding this in the sense of Frederick, that you have a challenge of, well, ST built security chips, but now this will be a new sort of kind of kick to that, bootstrap this. Think about it. Now I'll go through one after the other. Yes, Kari, you get started.
Thank you. I would love to have such a device, and I shouldn't be seeing problems, but I see the real problems lying there. That how can we share this health data between even our nearest and dearest, let alone then the different countries in Europe, even if we would get a secure thing from silicon to cloud, everything is secured and good. There's a lot of above that doesn't work. That should be working before that. But I mean, I would love to have a device that would tell me my cholesterol level every day. Can I eat the sausage, or should I be eating tomatoes? I don't know. But yeah, I don't think the problem actually is there in the security in this respect, but in other problems, that could be really good one to have the security from silicon to cloud. It sounds like a good goal.
Frederick?
think we have to be a little bit cautious regarding the timeline. I will be backing Frank there. I think that we have to remind that we do have a market to serve today with opportunities. And I fully agree with Bosch. If you look at what are happening for industrial and automotive today, it is a huge opportunity which required key investment. I think our CEO in the past 10 days made a lot of announcements, and it has to be in the mind of everybody. And on top of this, yes, for sure, if we can all together build innovation and capture value for all of us, for sure we will run for it. But it should not go in opposition with securing the market, what we serve today, and the opportunity that we have today also. And this is the balance of what we have to find. And in order to make sure that we will be able to seize these opportunities if they come, I think that standardization there is playing a key role. And perhaps it's one topic where we are not as strong as we may be. So it could be also an interesting discussion.
So Frank, maybe from your side, if you think of this, you mentioned that for you, automotive is way more interesting than health, because this is sort of prevalently there. If we talk about automotive and platform chips and count the number of cars that are being sold in Europe, I mean, if we start producing them on January 1st, probably January 15, we're done with all the platform chips that all of European manufacturers need. And I don't know any single European manufacturer that actually embraces your idea. The only one that does is Tesla. And the design house that helped design the Tesla chip, which cost $1 billion. If you talk to VW or Renault and you tell them you have to invest $1 billion in this kind of platform chips to really give this kind of security and trustworthiness, they all basically show you the door. And as I mentioned, I mean, Dreamchip was bought by a Chinese company, and Dreamchip was involved in the Tesla platform chip. And Dreamchip went around to Bosch, to all the car manufacturers in Europe. None of them said they want it because they say that's not interesting. So what is wrong? If you say that is the market, what is wrong? Or should we rather focus on something that is new, that is not there, established yet, like health, because somewhat the automotive market is broken?
Yeah, maybe some remarks here. I think the health market is also quite high interest, and maybe you know about it that also Bosch is somehow involved, but in a very small scale. I see the challenge about trustworthiness of data, but not so much in the microelectronics platforms here for the healthcare market. In the automotive business, it's a little different, because here we need platforms with a lot of calculation power, which has to be secure, which has to be safe. And there are quite a lot of challenges. And as we can see currently, there are only very few manufacturers able to produce such platforms. And as you mentioned, I don't know the dedicated case you mentioned here, but up to now, the car manufacturers are not semiconductor companies, and they expect what I think about it, they expect that there will be, or they hope that there are enough manufacturers which provide these semiconductor platforms. And up to now, their choice is very limited, which is also kind of danger. But I think they would be very interested if we can establish a player in Europe here.
Okay. Werner, do you still want to voice some of your thoughts that you are writing down right now?
I was just answering to a comment made on the chat. And the point that I really want to make here is that we should take this 6G thing, and I'd like to formulate it broader, in this connectivity thing as opportunity for us here in Europe to get something going. And of course, we need the microelectronics to get this thing going, because otherwise on the software layer and at Cyberus technology, we operate at the software layer now. We have to live with whatever hardware is out there. And on the other hand, also the hardware guys, they can only produce chips that can run Linux at the moment. So what we really need in order to enjoy the full benefits of this new technology is to have those two things working hand in hand. And you mentioned trustworthiness of data. Yes, indeed, with the security, it's all in there. Right now, if we look at the history of our computing devices, they come from the end of the Second World War, where all they cared about was calculating atomic bombs and so on. They had just numbers. And now this metadata, if you look at Facebook, if you look at Apple, this metadata is much more important, but we still don't have the mechanisms in order to protect this data. So we have to think this really on system level, but we have to have some sort of, well, if you look at email, PGP encryption, this came as an add-on. It was a nightmare to use correctly. Can we do something already where we have this sort of data protection baked into our data transmission, where if one component transmits it over the network somewhere else, where the processor gets the key together with the data, that's the kind of stuff that I'd like to see. And I think that's the opportunity that we have, where we can really build systems where we don't play catch up to some ARM company in the UK or whoever owns that company now, or some Intel, AMD powerhouses that can build processors that would allow also the small and medium-sized enterprises to come up with solutions, with point solutions that would be different probably for the healthcare market, for the industrial market, for the automotive market. And that's where we can get all this, well, I called it Cambrian explosion earlier today. And that's what I'd like to see, and where I have confidence that this will happen somehow, because there is just so much of opportunities out there.
Great. Mohand and Benoit. Now I think it's your turn to come up with answer. Mohand already raised his hand. Are you going to be able to address that in the way like Werner and others here have voiced it, that our next generation communication standard will really embrace this and we will have this kind of a cyber support? Or Mohand, what else did you want to say?
I wanted just to comment maybe on some of the remarks that have been made. So I believe that one of the main takeaway of the Corenect intermediate roadmap and proposals, and this was mentioned this morning by Björn and by Pete in Expert Group 2, is to accelerate the deployment of 5G, because I think this is really key in order to integrate this technology in our daily life. And as mentioned, of course, today in terms of specification and standardization, we are in release 18. Then before 6G is release 21. So in between we will have 5G advanced. This will take at least maybe 4 or 5 years, maybe 6 years. So in between, I think one of the key findings is that all these microelectronic platforms, or call it the processors if you want, will require in many applications this virtualization aspect. And even if you take, how to say, any of the use cases that are considered today in 5G and future 6G, we need this connection to the cloud. And in my view, the softwareization and its really deployment will also create many requirements, in particular in this microelectronic domain. One of the things that come to my hand is that, of course, I just mentioned before in my early intervention that this connection the moving to the cloud is a challenge, but there is another challenge, is the increase of machine learning and artificial intelligence. We would need to have dedicated chips for that, because this will help us in order to increase automation, reduce complexity. And of course, this will be required anyway. This requires also specific designers, just to resonate what Kari was mentioning. And for that, I believe that in Europe, we are also really just starting, and this will be critical in the future, let's say, development of these technologies, as we will see that these are playing a major role in the future.
Benoit. Yes, and then I wanted to ask Bernard a question anyway. So good, you raise your hand.
No, I didn't raise my hand, but if the question is what is an area we could focus to advance, I think the interplay between a wireless network and wireline network, especially 5G and TSN, that's a point where there is a lot to do. It has application in robotics, in manufacturing, perhaps in automotive, I'm not sure. But we have a TT Tech, which is a world leader in those time-sensitive networking technology. So I think that's an area we should focus, not just 5G or 6G, but what happens when we move between cellular and wireline, especially for the ultra-reliable, low latency applications.
Okay, and do you see that from your experience, that, because I mean, you've gone through the painful process of trying to get a foot in the door as a European startup, if I may call you that way. You see that this is possible to pull it off, to address the issues, or do you think that we still need something completely different?
Well, it depends. What is the question exactly?
Yeah, to be able to build these kind of platform chips in a way that we can address the challenges of trustworthiness, what Werner was talking about, what Mohan was talking about.
Yes. So one point with trustworthiness and security is each major block will have its own security standard and encryption methods and cryptographic methods. So we see them even because we supply or try to supply data center IO acceleration, and you have different cryptographic standards if you go to Asia or to the US, or of course we don't go to Russia, but they have different encryption methods. Now, if we want to be secure from your laptop to cloud, probably the move is on a homomorphic encryption method where you can only process encrypted data, and the cloud doesn't know what's inside the data it's processing, but then you have 100,000 fold increase in processing costs. So my point is that security looks very important, but in my opinion, maybe there will be too much pressure, I mean, the regulation, depending on the country, on the and then the technology that we really need, maybe it's not there already. So maybe it's a bit early, but that's my opinion. Now for the platform chip, we need the general purpose course, like I mentioned, and at Kalray we know that because we entered the partnership. We entered the Open Hardware Group organization. Why? Because we need to supply design of RISC-V, which are of EU origin, because RISC-V looks very nice, but in fact, all the implementation, most of them, they have item of US origin. So if you have US engineers, you have US data centers, you have whatever tainting of US will make those design under export control and re-export control. So it's very difficult to do the platform chip if you add the constraint must be sovereign and not subject to a foreign power export control. So that's one issue. But so we go with the open hardware group because the charter is not to accept contribution which are not EU sovereign. It's a trap. Open source doesn't mean it's free from export control. Open source is commercial licensing, and export control from different powers. It's another unrelated issue. So the platform chip is first, we have to find the general purpose, which are EU sovereign without items of US or China origin inside, and then we must complement the platform chip with DSP, with FPGA, embedded FPGA with non-volatile memory, and also a lot of I/O which are application specific. So for me, the piece of the puzzle, they are everywhere, but I don't see a short-term path to reach the goal of platform chip. But this is a strategic goal. I would agree on that.
Werner, you had some comments you wanted to make.
So it was just on the comments, a comment to what Mohand said about the virtualization and moving functions to the cloud. I mean, all this move with disaggregation of networks, which kind of produces opportunities potentially at the level of components as well. I was wondering, our understanding is that this move is potentially nice from a flexibility point of view. We understand, and I think this was mentioned in one of the speeches this afternoon, that this has some implication in terms of power consumption, for instance. One speaker mentioned the virtualization, which consumes 20% of CPU process in one of the speeches this afternoon. We understand that this is an approach which is also potentially increasing the attack surface, and which understand that at this moment in time, the performances are not necessarily as good as what they could be in other systems, which are more the classical systems that you get from vendors. So if you want to solve all these problems, you have to go into dedicated chipset developments, probably, and we have the accelerators from Kalray. We have potentially other type of developments to be made to make a processor capable of implementing a MIMO function as quickly as an ASIC design. I don't know, with as performance as an ASIC design. But these are very small markets. These are not very big markets. So what is the justification from the industry to invest in there? Whilst those which are investing today in this domain, which are coming from the processor side, and we know who they are, they have already much larger customer base to amortize their investments into this tiny bit of market, which does not represent high volumes. Because when you sell base stations, you talk about 1 million units per year maximum. You don't talk about the 1.4 billion smartphones that you sell every year.
Okay. Werner, you have a quick comment, and Mohand?
Yes, thank you, Bernard. I believe the initial use cases to really implement Industry 4.0 and all the kind of applications that were foreseen for 5G with the acceleration of deployment will end up that many of the applications that require low latency and also that require maximum of security. For example, for automotive, when you are speaking about autonomous driving or a fleet of vehicles, some scenarios at least are mentioning today that the connection to the cloud and the virtualization will play a role. So I agree that initially it's not a big market, but the idea is really to increase those kind of the potential to have this virtualization that will be expanded if it is successful, of course.
Werner, quick. Yes?
Yeah, I'd like to follow up on this virtualization thing, because that's a perfect example where we are living with old technology without having the processor and the whole system really optimized for the new use cases. You need more communication for this virtualization stuff to work efficiently, but the ISA of the processor doesn't do that. And that's an opportunity where we could really innovate. And yes, the base stations, they are fewer than the massive amounts of CPUs that are out there in the data center. But if we came up with a good virtualization solution for our base stations, it's only a question of time until we have the processor designers that are capable of competing with Apple so that they can put out those high-performance CPUs, and then we will also enter the mass market that goes into the hyperscalers, the Googles, the Amazons, and so on, where they also rely on virtualization. So
I would even take it further. I would say it's not only the processor, it's the multiprocessor system on chip architecture that has the right microkernel operating system, and then the virtualization actually does not consume more power. But Bernard, you had a quick question there or comment.
No, I was just saying fingers crossed.
Fingers crossed. Okay. Yes, but I agree. Honestly, with virtualization done right, the problems that normally it's not zero overhead, but it's like less than 1%. It really doesn't have to be a main part of it. But you have to do it the right way. Now, if we sort of zoom in on the really big question that we've been circling around. What are the conditions for the emergence of a European champion in this area? A new European champion or an existing company that becomes one of these champions? What do we have to do? Think of it this way. When Vodafone bought Mannesmann, Vodafone had a dramatically negative cash flow. Mannesmann had a dramatically positive cash flow. Still, Chris Gent, the CEO of Vodafone, sold the vision of building a true global player, and the stock price was at least 10 times more in terms of earnings per share than it was for the Mannesmann stock. And he was able to buy Mannesmann. Think of Tesla. Tesla's market value is at least 10 times higher in earnings per share than any European manufacturer. And if you talk to the finance guys, they say, well, they are building a computer on wheels. And if you think of like the ID3 from Volkswagen, the electric car, it's not a computer on wheels. It's the different components put together. Suddenly they end up with 17 processors that are trying to talk to each other, and they spend a year integrating this because the whole system crashes the whole time until they finally can deliver the first ID3. It's not designed around understanding the concept that we are building computers on wheels, we're building computers in our hands, we're computers on our healthcare, computers in everything. We will have to think differently. So how can we build this kind of a system? Knowledge? Do we need to build a new Airbus, a new Airbus? Or what do we have to do to wake up to bring this forward? Any idea? Werner has an idea from Intel's perspective.
Yeah, this is pretty much what I wanted to say with this DARPA analogy. If we come up with a goal and say we want to have a base station that runs virtualized software and has just 1% overhead for the virtualization, then I think that could be such a goal where we can rally the troops behind that goal, and we have software people, we have chip people that have to develop this stuff, we have processor IP people in there, we have Barkhausen Institute coming up with a microkernel that runs this whole stuff. But that could be this sort of function that pulls all the different pieces in Europe together. And maybe the base station is a bad example. I don't know, but that's the kind of thing that I could envision that really brings us forward in this space, where we have one far-fetched goal where we don't know how to get there because we still have to do research as well. But we have a concrete goal in mind. Let's say we want to have 1% performance or energy, whatever overhead, and we want to get there. And I'd like to have that in order to rally the troops and to get everybody working in the same direction.
Frank, do you think you can convince Bosch to do that way? I'm going to go through everyone now for a final statement.
Yeah, as you have seen, maybe I'm still thinking about it. I'm not sure because Bosch is also a company quite careful somehow with investments, and I think we need maybe a company who is really takes the chance, and I think the idea is good. I think that to build such a European champion who is really able to provide such a chip platform is a good idea, and also to bring really the troops behind such an idea and working several companies working in such a direction, because this is also quite a huge motivation. As you think also in the past, if someone says, okay, we want to fly to the moon or so, then there will be a lot of engagement, and often such a very simple vision is also very helpful for the people to run into one direction.
Okay, so honestly, you're just saying Bosch is not it. Kari, how about you? I mean, the Finns are the craziest car drivers, risk takers like nobody else on the road. The Germans have money like crazy. So
we take the money and drive away.
What is the combination we need to take this one step further? What is your view?
Yeah, you are right in that attitude, Gerhard. I mean, I hate myself for answering so badly on your previous question, and here I still am tempted saying why these things can't be done, but I'm switching to my normal self and don't care about the impossibilities. But there are some things that we've found out that the disruptive ideas, if they pop up in a large enterprise, they tend to walk out and make a startup. So the disruptive ideas are there. They may be already there, but they lack the kind of tender care that would bring them forward. And this was actually a question that I also asked my colleagues: what would it take to make the new champion here? And we should remove the bottlenecks from the SMEs, the startups path forward. They should be able to get funding in good terms. They should be able to get the connections. We are trying to connect our SMEs via these KDT and other programs to other European companies. We are quite shy as a nation, so we don't really talk too much unless asked about. So we try to force them into cooperation, and that's kind of the way that there's a lot of companies within Europe with great ideas that we just don't know of yet, and those need to come forward. We need to kind of lure them out into these programs, into working together with other companies, the Finnish companies with the German companies, the Finnish drivers with the German passenger, whatever. I don't know how you want to mix this. We just had on a last Saturday here, we had the most horrible snowstorm, and yeah, well, everything works fine even during that. So yeah, everything is doable, but we tend to find more obstacles than solutions. It's easier to say that why this can't be done than to say that this can be done, this will be done because of these and these things. And I would put the pressure on the SMEs, the startups, and let them develop their dreams where they are, because their dreams are still new, and the last enterprises' dreams are maybe concentrated on the next quarter of a year.
Okay, Benoit, so with that, it's your turn, obviously, because you're Mr. Startup here. Next to Werner, and tell us, are you going to be able to pull this off?
We hope so. So your question is that, well, I think Kalray has to struggle to survive in the commercial market as an open field. and we simultaneously try to advance computer architecture. So I think, yes, if we manage to survive, we will be part of some interesting thing. But my point is more like what action EU should take. I can take as an example my academic colleagues doing computer architecture. What do they do in practice? They play with FPGA design, and very few of them twinkle the RISC-V. And the others, they will study what is the hypervision structure in Intel or whatever. And I think if we want to have more talent and more interest coming, there should be a way for easy access to silicon design in advanced technology node from academic. I don't know what would be the means in practice, but if you look at the history of RISC-V, the Berkeley team, they could iterate many silicon before they converge to the first RISC-V IC and implementation. And maybe, I don't know the details, but maybe this is lacking a practical way to achieve access to silicon manufacturing design with some EDA tools, which are less expensive, from good quality IPs that you need for your chips, the I/O, the DDR. And that's, for me, a big reason why we don't see more talent in computer architecture coming from education and universities.
Okay, that's a good point. So a rebooted Euro practice at a much bigger level. Frederic, now you're the big chip guy here. First, the small chip guy, is ST going to make it? Or do we need to start something anew, get a new player on board, where ST maybe is partnered in a joint venture?
No, but I think that the discussion so far is very processor focused, which is an important topic, but as we discussed with Frank, it's just part of the equation. So if you are looking to what is happening right now, I think there is a lot of opportunities for Europe, because we are all growing this market today. And the point is, if we are willing to go outside the perimeter that we are able to capture today, and as it has been said, big players as us for sure will be opportunistic, but maybe we are not, let's say, the more agile guy in order to start this. But let's give a quick look to what Chinese did. Today they have Longson, they have Python. It did not happen overnight, and it maybe happened for political reasons. So that's also part of the equation. It's not just the volunteer of the business ecosystem. That's also part of the discussion. So I think that we have to be realistic. It's not just on us industrial players. Where we as Europeans, are we willing to go? And this is a political statement for sure.
And Mohand, you think we can see Nokia really kick down and the market cap goes 10x up and everybody thinks you're going to pull it off because you're going to design your own core platform chips just like Tesla did?
I don't know. And this is why I'm here. You know, it's I think in my view, at least in the European ecosystem, we will need for sure more collaboration. And possibly from this collaboration will emerge maybe one or multiple champions. I think we need to work together to facilitate access to technologies, to capital. I think access to capital is very important, to talent, as was mentioned, and maybe to make this some of the supply chain, in particular in this COVID situation, more resilient and facilitate the trade.
Thanks. Bernard, are you happy? It looks like we're going to really have to seed some new, and then maybe that will become the starting point for big guys to focus on, and then kick,
your
kick down, or what do you think?
Your question, Gerhard, is supposed to be subject of recommendations from Corenect, for which we are the customer. So we are waiting for you to provide us with the answer. But from a personal perspective, and again focusing on connectivity, We have a notion in Europe which is about lead markets, which I believe is something very powerful. What did happen in 5G and how did the 5G ecosystem develop? It did develop even before the standards were finalized, even before the research was completely finalized, because a number of key players were ensured that there would be already deployment initiatives taken up. I mean, why did some microelectronics vendor in the US invest $1 billion in an RFIC capability even before the standard was kind of finalized? Because they knew that operators would go for contracts at 28 gigahertz for the US and some parts of Asia. So it's very important in my view that whatever kind of connectivity initiative we can take in Europe for the future, at some stage we can have very early in the process a certain visibility on how this is going to be implemented and how this is going to be deployed. And that's one of the reasons why we are potentially a little bit suffering in Europe at this moment in time, because many people are complaining that 5G does not deploy in Europe as quickly as it should. But I think this is something we need to potentially correct with another generation if it comes across in the next few years. It's very early in the process, have already some well-identified potential deployment initiatives. And that's the reason why I'm thinking of sectors like healthcare, because this is a domain where the public sector can have an influence and can very early in the process plan for something. Now, if we leave it entirely to the pure market forces and we say, okay, we develop the technology and we see what happens, whoever buys it will buy it, I think it's not enough. So I would be tempted to believe that in the future developments towards 6G, we need again to have something much more, let's say, visible or bold in terms of deployment in such a way that the investments can be stimulated in the ecosystems early enough in the process, including the investments in microelectronics.
Well, thanks, Benoit. You gave us another little point to think about, that is, we can come with the nicest ideas if we don't think of the regulators on the market access from that point of view. It might be disturbed and destroyed. Well, with that,
just one comment on that, because this is a point I wanted to say and I didn't say. I think it would help very much also if we had, like in the US, in Europe, but unfortunately it doesn't depend only on us, it's really in the hands of the member states, is to have some very early availability of the frequency bands, even for vertical industries, you know, some specific chunks which are not necessarily reserved for MNOs, but that can, where the ecosystem can play with and can start off implementing their own systems.
I totally agree. Wonderful. So with that, I want to thank you all for participating in this lively discussion. Mohan, Frederick, Frank, Werner, Benoit, Kari. I hope I didn't forget anybody. Let's see. And make sure that we really have, I think, a positive way of looking at this. What we learned is there exists clearly a chance. Everybody here worked on how to make sure that Europe can actually capture this chance. And there are different ideas that came to play. And certainly there's not one solution that we come up with, which is the golden solution. But it seems that on the way to 6G, which is still 8 years away, hopefully, we have plenty of time to seed new companies, to foster new ideas, to make sure that new ideas come to play. And also by doing so, giving the big corporates that we have in Europe a chance to see what is possible outside their standard way of thinking, and then pick up those pieces and just start zooming along. With that, let's hope Europe really makes this happen. Thank you all for participating. And with that, I return to Janine for the closing remarks.
Thank you, Gerhard, and for the moderator of the panel, and also all the panelists for your excellent discussions. So I think with that, I would say possibly we raise more questions than answers today in our discussion. I think this is just starting point. So we will continue this discussion and also take many inputs and good results from this workshop back to our work inside Corenect, and to deliver our final roadmap and also recommendations and to Europe to act. With that, I thank you again, all the participants and all the speakers for the workshop. And I wish you a pleasant evening. And later we will send you follow-up email to show you the, when the video and the slides are online. And also we will be happy to hear your opinions about our industry roadmap with this public consultation. So I hope everything is okay, and thank you, and good night or good evening. Bye-bye.
Bye.
Thank you. Bye-bye.
Thank you.
See you,
Bye-bye.
Thanks. Bye.
Bye-bye. Take care.
Merci.